of things. I want to welcome you guys to this workshop. Me and Samil have worked really closely on making this awesome. I know we have various levels here, so if you have any questions or you have more deeper questions for those of you who are very senior in using Hudi, definitely ask them. I want to introduce a couple of people to you before we get started. There's me, Nadine. I'm part of the Hudi community and I'm a contributor to Hudi, and I'm at One House. You guys have probably seen me on the chats and stuff trying to answer your questions. I definitely do my best to get to them. And please keep asking questions so we can keep growing together. I also have Sumil with me, which I'm sure many of you are familiar with. Sumil, do you want to give a quick intro?
Hey guys, I'm Sumil. I work as a lead data engineer at JobTarget and a member of Apache Hudi. And I have been teaching people about Apache Hudi through my YouTube channel. So nice to meet everybody here.
We also have Jangath from AWS joining us today. He'll be giving a deep dive on the glue portion of it in this presentation today. And he was so kind of us to give us the demo environments as well that we'll be using the next hour or so. So Jangath, do you want to give a quick intro to yourself?
Sure. Hi, everyone. My name is Jagannath Achari, and I go by Jagan, and I'm a solutions architect at Amazon. And I've been here at Amazon for close to 5 years now. So as a solutions architect, right, I work with Bay Area ISV customers to help build their SaaS solutions on AWS. So nice to meet you all. Like Nadine mentioned, I'll be giving you a quick overview about the lakehouse approach, which you can build on AWS.
And then I also want to take some time to also introduce Sudha. I work really closely with Sudha at One House. She's a PMC member of Hudi, and she'll be helping with your questions and stuff as we go through the workshop and the presentation. Sudha, do you want to give a quick intro to yourself?
Oh, wow, that's a good enough intro. Yeah, I'm a software engineer at One House, and I'm a PMC member of the Apache Hudi project. You have seen me in Slack on and off. I'm a very active member in Slack since 2017. I'm glad to meet you all, and I'm here to help the team through the workshop.
So again, we're at various levels and people joining today. Please take advantage of the sessions with your questions, even if it's related to the workshop or not related to the workshop. Or if you have more questions about architectures and things like this, Sudha and I and Sumil and Jangath will all be here to help answer your questions. So this is a great one-on-one time. And besides, going through the workshop, we definitely want to make it interactive and hope you guys get something out of it. So please take advantage of the next 4 hours with us live. Okay, with that said, I'm going to go ahead and kick off the presentation. So we already kind of went through intro, so I'm going to skip through that. You're seeing my dog here. Samil already gave an intro. And then we have Jangath, who also just gave an intro. So I'll skip through those right now. And then we're going to go through the agenda. So in the agenda today, we're going to do an AWS overview on services with Glue with Jangath. And then from there, I'll do a Hudi overview of features and services. And this is going to be like a high level overview of what is Hudi, how does it fit into the lakehouse and things like this. We're not going to go too much into like the configs and things like this, but if you guys have more specific questions about configs and why we're using it and things like that, when we get to the workshop portion, that'll be a perfect time to ask those questions and things like that. Like if you want to know how to start your clustering service, what configs you need to get started, or how do you deploy in an asynchronous way, all of those questions should come in when we actually do the workshop. And then Sumil's going to do a workshop overview and talk about what the architecture looks like and some of the things that we'll be doing. We'll kind of break for a few minutes, and then we'll actually get started with the workshop right after that. So I'll go ahead and pass it to Jangath for the AWS Glue and Apache Hudi overview.
Yeah, thanks, Nadine. So team, I'm going to briefly talk about how you can accelerate building a lakehouse architecture on AWS with the Glue and complemented by Apache Hudi. So can we go to the next slide?
Yeah.
So when AWS customers, right, what we have seen is like when they're investing their resources in building databases, data warehouses, data lake solutions, they often put these efforts in isolation from each other because you have multiple different teams, working on these various different projects. So each initiative comes with its own separate layers of data ingestion, storage, management, and governance. So the result of these efforts is, right, you basically create a lot of data silos in your organization. So this basically increase the data ingestion complexities, excessive data movement, and also data consistency issues. So these issues often prevent our customers from, achieving deeper, more insightful data understanding. So, so the question is like, how do we overcome these challenges, right? So the answer to that is the lakehouse approach. So the AWS lakehouse approach, right, aims to integrate the best aspects of the 3 data solutions that we have, right, like data warehouse, databases, and data lakes into one unified user-friendly solution. And to build a data lakehouse, a lakehouse on AWS, the main integration platform, right, which we recommend is the Glue integration system. So we'll talk about the Glue integration system now. So Glue is basically, as many of you know, is a serverless data integration service, right, which enables discovery, preparation. Sorry, was there a question?
Nope, go ahead.
Okay. Preparation and combination. So basically, Glue is like a serverless data integration service, which enables the discovery, preparation, combination of data for multiple purposes, right? It could be for analytics, could be for machine learning, and could be for application developments. So it basically offers a seamless and quick way to start analyzing your data, transforming the data analytics timeline from weeks to months to, a few minutes. So as you can see, so this picture basically depicts the various different components of the Glue integration system. So we have components which are designed for connectivity, simplification of data discovery and governance, authoring and monitoring, right? So there are many components here, just to name them. It's like you have the Glue connectors, crawlers, data catalog, schema registry, Glue data brew, studio, and the Glue development endpoint, right? Each playing a significant role in the data integration. And we can also integrate with various other different sources, right, which are not native. Like, for example, you want to pull in data from Salesforce, right? So for those, Glue offers you, options, through the means of connectors. So these connectors are available in the AWS marketplace, and the Glue crawler, you can allows you for efficient population of the Glue data catalog with tables. Our data catalog basically serves as the central metadata catalog for all your data needs. And the schema registry basically enables you to discover, control, and evolve your data stream schemas. So the Glue data brew basically facilitates data scientists and analysts in cleaning and normalizing the data, basically reducing the time it takes to clean up your data by up to 80%. That's what we have seen with our customers. And then we also have the studio and the development endpoint, which are available for data curation. There are a couple of other components also. AWS Data Exchange, it's like a marketplace where you can exchange data with the third parties. Then there is also DQ, which is an open source data quality library developed by Amazon. Okay, so those are various different components, but how do you put all these together to create a data lake, right? That's what we are going to see. Create a lakehouse architecture, right? So that's what we are going to see in the next slide. Can we move on to the next slide, please?
Yeah.
Okay, awesome. So, so this one basically shows like how the various components in Glue, the Glue data integration system, help you put together a lakehouse architecture in a relatively less time. So the flow starts with the Glue crawlers, which are scanning data from various sources and populating the data catalog for your lakehouse. So once cataloged, you apply fine-grained access controls using a service called AWS Lake Formation. So data is also curated using Glue Studio, Glue Dev endpoints, Glue Data Brew, right? And curated from S3 for downstream analytics. So Glue facilitates data movement to end from your data lake, databases, data warehouses using the Glue connectors. So one important thing is on the right side, you can see the lakehouse architecture. And on the data lake, we've shown this component Hudi, right, which we are going to take a deeper dive today. So Hudi is basically stands for Hadoop upserts, deletes, and increments. And this is basically an open source data management framework that is designed to facilitate quick updates and inserts on large data stored on S3. So integrating Hudi, right, with our lakehouse architecture basically improves the efficiency of data management on S3 data lakes. So using Hudi, your users can basically insert, create, update, and delete data in S3 lakes in similar way to how they do it in let's say, a traditional relational database. So Hudi operates within the Hadoop ecosystem, allowing you to leverage existing data lake technology and infrastructure. So the framework has support for incremental processing, which basically helps ensure that only the most recent data is transported for processing. So it reduces the time and resources needed to obtain actionable insights. So this basically amplifies the power of lakehouse model and enables real-time analytics and facilitating the handling of CDC as well as simplified data pipeline. So Hudi can also be it can be used with other data processing tools like Apache Spark, Hive, and Presto, which are also available on AWS. So it's also integrated with the data catalog, so which makes your metadata management much easier. So by adding Hudi, right, to your data lake on AWS, you're basically obtaining a live data lake, right, where every change made to the data set is immediately available for querying. So the ability to manage data on record level basis and make near real-time updates reduces the complexity of the data pipelines. So integrating Hudi with Glue in your data lake basically improves the lakehouse architecture to new heights and making it the most comprehensive and effective data solution for your organization. So we're going to take a deeper dive, and we're also going to build a rideshare app using Hudi and Apache Glue. So yeah, I'm as much like you, I'm also eager to follow along the workshop. So I'll hand it over to Nadine for the next steps.
Yep, thank you. And if you guys have any questions about the Glue, AWS Glue, or the lakehouse architecture with Glue and Hudi, please post them in the chat. Okay, so let's start with the lakehouse overview. So Hudi developed and basically started at Uber around 2016 to address the inefficiencies across ingest and ETL pipelines during its hypergrowth stage. And at that time, Hudi was dealing with petabyte data, so a lot of data. This is back at 2016, so that's like crazy. If you walk through an example of an Uber ride, a rider requests a ride, then it gets the ride, and then a rider, and then you have an end ride, right? So that's what a single trip entry looks like in a trips table. So a trips table can experience many updates during this life cycle. And before Hudi, large Spark jobs were used to periodically rewrite entire data sets to Apache HDFS to absorb upstream online tables of inserts, updates, and deletes, reflecting changes in the trip status. And if we remember, HDFS is an immutable store. And this process was not only inefficient, but also harder to scale. So how do you bring transactional guarantees to a data lake? Because the data lake doesn't have that. And especially when you're working with big data. And how can you also effectively work with streaming sources where you can handle bursty writes, late arriving data, and so on? And this was inspiration behind the creation of Hudi. But how does Hudi fit into the lakehouse? So typically you'll be working with all kinds of sources, including streaming, and data will be stored typically in S3, and you'll have what we call a table format. And I say table format conditionally here because when I get to the bird's eye view of what is Hudi, this table format is only like a component of that. And so by adding, Hudi on top of like your object store, you basically supercharge your object store with so much capabilities and services that it doesn't have alone. It's kind of like, giving those superpowers. So Hudi gives a lot of superpowers. And these superpowers help with data ingestion, metadata management, managing your table sizes, and so much more. So after data is in your lakehouse, you can integrate it with any compute engine to perform queries and eventually use the results to perform analytics. But why use a lakehouse like Hudi? Why put like something on top of your object store with Hudi? Why not just use S3? And so this brings us to this slide here. So we talked about why Uber decided to build Hudi, but why didn't they just stick with S3? Well, object stores are basically immutable stores that don't provide ACID guarantees and have a set of properties that provide and doesn't have a set of properties that provide like guarantees or data integrity and so much more. Object stores don't enforce any data or format. It's just basically a blob storage with no constraints, no schema validation, and so on. And in other database systems, you'll want to work with structured or semi-structured data in which you can either define the schema or auto-infer the schema at read time. Finally, there are no, object stores don't have any services support for indexing, allowing for efficient querying and upserts. It's hard to query and filter data, especially if you want to do, complex SQL analytics like aggregations, filtering, and joins. And also there's no way to kind of maintain your table's health with services like cleaning, data clustering, and things like that. So you can think of Hudi as bringing data warehouse capabilities to the data lake. In addition to being able to store, in addition to your data lake being able to store petabytes and exabytes of data, by using something like Hudi as part of your lakehouse architecture, you get ACID guarantees and so many other services and features. So this is a bird's eye view of the Hudi platform. And earlier I mentioned that Hudi is conditionally a table format, but it's really so much more than that. It's actually a full-blown platform. Hudi has many services to ensure you get read and write optimizations. So at the bottom with the green boxes, you pick your lake storage that you want to store your data, and then you have an open file or data format that you'll use, for example, Parquet and Avro. And on top of that, this is where we get to the services and features that Hudi offers on top of your lake storage. So there's a transactional database layer. Here you'll see there's automated table services, indexing, even table formats, and then you have concurrency control and so much more. And on top, you have the execution runtime layer where you can stream from different platforms. You can do batch ingestion, streaming ingestions. And then there's this query interoperable component where you can integrate popular query engines to Hudi to query the data and then use it for analytics. So this is like a high level overview of lake houses and architectures. Now we're going to double click a little bit into Hudi and offer and go over the different table types and some of the services and features that Hudi offers. So one of the table types you can use, and that we'll actually be using in this workshop, is a copy on write table. Copy on write table is basically a table type where when you ingest data, there is a synchronous merge that happens as part of the ingestion where you form new versions of Parquet files. You don't have any log files or anything like that. So this means that with copy on write tables, there is a higher write amplification, but the read amplification is a lot lower because you can just read the data or just directly read the Parquet files. And so if you're not too concerned with like how fast your writes are being written, copy on write table is a good choice. If you're dealing with more streaming data, you'll want to use like a merge on read table, which I'll go over in the next slide. So copy on write tables have a couple of query types that you can run. There's what we call a snapshot query and an incremental query. So a snapshot query is basically returning all the results of the current snapshot of your Hudi tables, including with updates. Incremental query just basically grabs the changes and reflects those changes. So if we look at commit time 0, you have a snapshot query of A, B, C, D, E. And this is because this is your first ingestion. So you're going to return everything. And also the incremental query will return everything since it's your first commit. There's nothing new that's changing. Everything is new. But if you go to commit time 1, you'll see that A goes to A prime. So we have an update on A. And then you also see D goes to D prime. We have an update on D. So if you run a snapshot query, you're going to return the current state of the table, which is A prime, B, C, D prime, E. But if you run an incremental query, you're just going to return those updates, which is A prime and D prime. Now, if we look at commit time 2, A gets updated again to A double prime. And then also we have E gets updated to E prime with a new update. And then we have a new insert F. So if you run a snapshot query, you're going to return the current view, which is A double prime, B, C, D prime, E prime, and F. But if you just ran an incremental query, you're just grabbing those updates. So A double prime, E prime, and F. And this is very fundamental because when we get to the timeline and the incremental processing framework, this concept of incremental query we'll come back to it a little bit later. But right now, just understand that it just grabs the updates of what's being added, which field is being updated. So the second table type that you can choose in Hudi is called a merge on read table. So merge on read table is a little bit more complicated than a copy on write table for a couple of reasons. One, when you first form an ingestion on merge on read tables, it gets written into Parquet files. But anytime after that first ingestions, if you have more writes coming in, they actually get written into these log files. So you'll see on the light yellow orange box and deep orange boxes, we have different log files. And then at compaction time, you compact all the log files and form a new version of the Parquet files. So if you look at commit time 3, you'll see that there are new versions of Parquet files. And so this is why merge on reads have faster writes. You just directly write to these log files. There's no merge happening at the time of ingestion. But when you run compaction, you run this big merge operation where you're merging the log files to form a new version of Parquet files. So the read amplification is a little higher in merge on read tables. So we kind of covered snapshot reads and incremental reads. These are the same concepts from copy on write, apply the same way on merge on reads. With any updates or getting the current view of the snapshot of what the table looks like. With snapshot queries, it'll grab, even if it's written to log files, it will grab that current snapshot, including what's being added to the log files. But a read optimized query is a little different. It's kind of reading older data until that's at the time of compaction. So let's say at commit time 0, your snapshot, incremental, and read optimized queries will return all the same results because it's just the new data that's your first insert, right? But if you look at the read optimized query on commit time 1, it's still returning the results from commit time 0. So it's returning basically just, you can think of it as just returning the Parquet files or the current view of the Parquet files. But if you go to commit time 3, you see after the time of compaction, we form a new version of a Parquet file. So now if you run a read optimized query at commit time 3, you're going to return that current view. So it'll be A double prime, B, C, D prime, E prime, and then the new insert F. And so if you guys have more questions on this, please ask them in the chat. But this is the 2 table types that you should be aware of and leverage depending on your use cases. And if you have questions, yeah, please post them in the chat. So the other part I want to talk about is Hudi's timeline. Hudi's table maintains all operations to the table in a single timeline composed of an active timeline, and there's also what we call an archive timeline. The active timeline stores all the recent instance, while the archive timeline just stores the older instance. And an instant is a transaction where all respective partitions within the base path have been successfully updated by either a writer or a table service. So instances that get older in the active timeline are actually moved to the archive timeline at various times, depending on how you set your retention settings and stuff. So an instant can alter, and depending on how you're writing data, like each batch ingest that you have will be what we call a commit. So the active timeline is basically a source of truth for all operations and services that happen. So this guarantees that the table is in good state, and Hudi can provide read-write isolations based on the timeline. So for example, if data is being written into a Hudi table and it's in a state of a requested or in flight, the query engines won't read the data until it's fully committed. So one of the concepts I want to talk about is like in the Hudi timeline, you have different actions. You can have a commit, you can have a rollback, you can have a clean. These are all things that are happening within your table, but each action has a state. So there's an in-flight, there's a requested state, there's an in-flight state, and then there's also a completed state. And these states mean that either, the service or transaction is, triggered, it's in flight, which is being, actively worked on, and then finally completed, which is completed, the transaction's complete and it's committed to the timeline. The active timeline is under the .hudi metadata folder, and you can navigate it in your Hudi project directory. And I've shown what that looks like here. The timeline is really important when we get to incremental processing. So I'll kind of refer back to the timeline, but I wanted to mention it at a high level, that this is something you should be aware of. And I'm sure a lot of you that are using Hudi quite extensively are probably rely on the timeline quite a bit. The other thing I want to mention is the archive timeline as well. It's a directory used to store successful and older commits that we don't touch on a regular basis. You can kind of think of it as like cold storage for older instance. The older instance from the active timelines are batched and merged together in a log file and then sent to the archive timeline. This helps keep the active timeline fresher with data so we can, easily access it at low latency. And in diagram here, I am in the .hudi folder and I just highlighted what the archive timeline looks like. You'll just see archive, you can go into it, and then that's where it's stored. So now we're going to get into Hudi's table services. So as I mentioned in the platform overview, it's not just a table format. They're automated and built-in services that you can leverage for Hudi to ensure performant table storage layout and metadata management, which are can either be invoked synchronously after each write operation or asynchronously as a separate background job. So if you're running the services asynchronously, writers like Flink and Spark, if you run them in continuous mode, can invoke the table services and you can run it as a separate job. But in short, Hudi is designed with built-in table services and a self-managing runtime that can orchestrate various services to optimize everything internally, meaning that you don't have to run commands to do that yourself. Hudi just takes care of it automatically. One of the table services that we'll kind of go over today is clustering. So I'll go over a high level overview of like the motivation about clustering. I won't get again too much into the configs, but when we get to the workshop and you have more of those questions, that's a good time to bring them up. So in data lakes, in data lakes, hold on. In data lakes and warehouses, one of the key trade-offs is between write speeds, which is data freshness, and query performance. And basically, data writes are faster with small files since data is processed as soon as it's available, avoiding an intermediate aggregation step, to combine the smaller files to larger ones. But as some of us may be familiar with, query performance degrades poorly with a lot of small files, because small files cost more disk seeks and slows down compute and downstream, distributed computing applications. And so this is the thing where we can get into file sizing. Hudi has a separate service for also file sizing, but for clustering in particular, one of the main motivation is to decouple file sizing from ingestion into a separate table services, which is clustering, where you can combine the smaller files to larger ones without impacting write speeds and data freshness. And the other part is that you'll want to improve query performance by you can reorganize the data layout through different techniques, and you can sort data on different columns, and the clustering service helps you to do this. So it helps improve your file sizing without compromising ingestion speeds, and also can improve query performance because of the data layout customizations you can do. The other service that we're going to have as well as the cleaning service. So it's a crucial component of Hudi's data management capabilities. And its main purpose is just to remove old, unused, redundant files to help free up storage in the data lake. You can customize, how you would want to clean the data to maintain it through the various settings. But this is mainly what the cleaning service is. It's a little bit simpler than the clustering service. So, but with the cleaning service, you can improve storage costs. You can improve query performance. And he also has a big role in like data inconsistencies. If you have multiple outdated versions of the same file, they can coexist in a data lake. You can increase the risk of data inconsistencies. So the cleaning service helps with that. And then finally, I think it's worth mentioning, compliance regulations. You might have to clean data and delete it and things like that, depending on what the regulations are. So the cleaning service definitely helps with that as well. And then there's many other services that Hudi offers. I'm just highlighting the ones that we'll kind of touch at the workshop, is the file sizing service. We talked about the small file problem when we went over clustering, but Hudi does have a file sizing service to help improve read performance and processes and things like that. And all of this is automated as well as Hudi. So now the other thing that we're going to use in Hudi is the HiveSync catalog. The HiveSync tool is a powerful tool that facilitates seamless synchronization between Hudi and the Hive Metastore. And it's just a convenient way to integrate and synchronize data between Hudi dataset and Hive tables. And then we'll be using this capability in the workshop as well when we get to the Glue portion. So the tool provides specific integration capabilities with Glue Data Catalog, and the Glue Data Catalog is, obviously fully managed by AWS, and it's used for storing and managing metadata about the data sets within the AWS ecosystem. So by leveraging the Hudi HiveSync tool and with the Glue Data Catalog, you can easily synchronize the metadata between Hudi datasets and the Glue Data Catalog. And this synchronization ensures that changes made to the data in Hudi, such as like schema updates and things like this, or partition changes, is also reflected in the Glue Data Catalog. Hudi, this data catalog sync is a pluggable implementation. There are many syncs available, like Data Hub and stuff. If you want to learn more, you can go to the Hudi website and check it out. But we won't get into the other ones because it's not relevant to the workshop. And the other thing that I think is really important to talk about is the incremental processing framework. This is like one of the main hallmarks of Hudi. As far as I know, Hudi is the only lakehouse platform that does incremental processing, where you can just grab the changes of what has been updated for a field and then query it and then use it and then pull it for your downstream tables. So we'll go over this. So basically, in the incremental processing, we talk about commits happening to a timeline. And when you have a commit, which is a type of action committed to the timeline, there's a timestamp associated with that commit. And if I go back to the timeline, I'll go back. I can show you that there's a timestamp. But basically, when you run an incremental query, so if we reflect back on the table types that we went over, there was an incremental query for COW and MOR tables. When you run that incremental query, you can specify the timestamp that you want to compare it to the timeline commits. And all commits that come after the timestamp are provided with the query return. So let's say you have an incremental query and you want to get all the updates after, I don't know, June 21st. By running an incremental query, you can check the timeline, the commits in the timeline, because each commit has a timestamp, and just return those results without recomputing the whole table. And if you're dealing with petabyte and exabyte data, some of us may have, you can appreciate the value that this brings to the table, no pun intended. Incremental queries can be bound, so you can specify a begin timestamp and an end timestamp. And then what's returned is all the commits within that range that you specify. And if no timestamps are provided, you'll return all the commits. So the reason I'm talking about these things, I'm trying to link together the timeline, incremental processing, and some of these fundamental things. So when we get to the workshop, you'll understand some of the architectures behind of what we're doing. In the workshop, we're actually going to be doing an incremental update with a tipping later. So we'll run, a full cycle of writes, and then some user 2 days later will tip, a generous portion to the writer. And then we're going to do an update, and we're going to show that in the workshop as well. So this example will be reflected in the workshop. And then finally, I want to wrap up with built-in functionality with Hudi. Hudi has built-in and automated functionality for deduplicating records that are being inserted. If you've worked with streaming data, you can appreciate that. There are multiple writers available to write data into the Hudi table. So you have Delta Streamer. I think maybe some of you have used that with multiple source connectors like Kafka. You have the Flink writer, Spark Data Source, Spark Structured Streaming, and so on. So you can control how you write data, partition data, and read data. There are automated, built-in table services, which we kind of just covered. You have metadata, you have the Metastore catalog sync, you have the metrics config, you have a flexible record merge logic. So let's say you have two records, an old record that exists in the table, and you want to bring in a new record. You can kind of specify how you want to merge those records. For example, do you just want the updates to go in, or do you want to not do that? How you merge records is is also provided by Hudi. Oh, then the other thing too is disaster recovery. So one of the things we also are going to touch base on is the save point. So disaster save point is basically a mechanism to just save the current state of your table. And then you can restore it. Let's say if you have something crashed or something went down, you can actually restore the table to its former state by using save point. So it's a way to kind of to keep snapshots of your table so you don't lose all the work or all the updates or all the data that you've done. And now I'll pass it to Samil for the workshop overview. Samil, I'll stop sharing and then you can pick it up.
Thank you, Nadine. Let me share my screen. Do you guys see my screen now?
Yeah.
All right. So we are gonna build a lakehouse architecture. We'll have 4 different tables in DynamoDB. We will stream the data to S3 through AWS Lambda function, creating a bronze layer of raw data. And then the next slide. So these are gonna be the DynamoDB tables. We'll have a table for tips. We're gonna have tables for the driver. We're gonna have a table for rides and user. So the user table will have attributes such as a user ID, a name, a city, a state, a phone number, and a created ad. So this is the information about the user who's gonna take a ride. Then we have a driver table in DynamoDB, which contains information about a driver. We have a driver ID, which is a unique identifier. We have a name, phone number, email, city, state, car make, car model, license plate, average rating, number of rating, and created ad. Then we would have a rides table in DynamoDB, which will contain information about a ride, which will have a ride ID, which is a unique identifier. We'll have a user ID, a driver ID, a ride date, when the ride was taken, what time it was taken, the pickup location, the pickup city, the pickup state, the drop-off location, the distance traveled, the ride duration, how much you paid for the particular ride. You will also have a DynamoDB table for tips, which contains information about a user tipping the driver later on. This will contain a tip ID, which is again a unique identifier, a ride ID, information about a ride, so for which ride you are tipping, and the tip amount, of course. In the step 2, we will utilize AWS Glue to catalog the data and incrementally ingest it using Glue bookmark to create Hudi tables, resulting in a silver layer of a semi-processed data. Step 3, we are gonna create a gold layer. We're gonna implement an incremental ETL. This processes will fetch the necessary information from the Hudi tables, allowing us to create an earning fact table. The fact table will contain valuable key performance indicators that can be used by businesses to gain more insights into the driver earning. Now, I do want to add one point over here. We are going to use incremental ETL in Apache Hudi. So we're going to incrementally fetch data from rides. We're going to incrementally fetch data from tips. We're going to perform a join, and then we're going to basically insert that into a fact table. Later on, we will see a nice example where we're going to tip the driver, which is considered as a late arriving update. We're going to incrementally fetch tips, and then we'll basically update the earning fact table. In step 4, we'll use Athena and Quicksight to query and analyze the data and build near real-time dashboards. We will also provide an event-driven alert mechanism in any event when any Glue ETL pipeline fails. Now, let's consider what is a dimension, right? So a dimension is used to categorize and filter the data in a fact table. In the ride-sharing application, we are going to have a date dimension. A date dimension can be used to aggregate and filter the data. And you can, let me click on admit. So you can use the date dimension to get insights such as, okay, what is the revenue over a year, over a month, over a day? How many rides were taken, right? So we'll have a date dimension there. We would have a fact table. So a fact table represents a collection of measurable and numeric data related to a specific business process. In the workshop, we're going to have an earning fact table, which will have key information about the earnings of a driver. This earning can be analyzed over a date dimension, and we can also drive insights such as who are the top drivers, making most amount in the tip. Let me click next. And then we're going to use a star schema over here. One of the most popular data modeling techniques in data lakehouse is star schema. The star schema is widely used due to its simplicity, performance, and effectiveness in supporting analytics and reporting. It involves organizing data into a central fact table surrounded by dimension table, forming a star-like structure. This technique simplifies data analysis and enables efficient query performance, making it favorite choice for building data warehouses. So this is what we're going to build. So we would have a driver Apache Hudi table, we'll have a date dimension, we'll have a write table, we'll have a user table, and we'll have tip table. And then we're going to make a fact table, which is the driver's earning. And now, as you can see, you can join the driver earning on a date dimension and aggregate and filter the data and perform valuable insights on that. You can also see who are the drivers making most amount of the tips, right? So this is what we're going to be building. Over to Nadine.
Yep. Okay, 1 second. Okay, so we're coming towards the end. So I'll just mention a little bit about the community. The community is always buzzing, and with we have multiple support. We have support for multiple cloud providers. Hudi's community is very large and diverse. So with you guys and so many others in the Hudi community channels, I want to thank you. For those of you who are looking to build with Hudi and integrate it with your infrastructure, please ask your questions, and we're happy to also listen to what you would like to see in Hudi in terms of product features and things like that. I've sent so many emails. I hope you guys are a part of the Hudi community, and especially in that channel, the AWS Hudi Ride Workshops channel. If you're not, you can scan the QR code now and join that. And if you love and use Hudi, please give us a star, a GitHub star. And with that, we're happy to open the floor now. You can unmute yourselves and ask us like a Q&A. And then from there, we'll take a 5-minute break. So we're doing pretty good on time. So I'll open the floor now. If you guys have a Q&A, feel free to unmute yourselves. There are 4 of us here to help answer your questions across the board. So I'll open up the floor now.
So Nadine, I have a question. So you mentioned about the table services like the clustering and the cleaning, right? So I think, is it recommended to use those services as part of the ingest job itself, or is it always good to use it as a separate scheduled job, maybe out of business hours, and do something like that? So, and what is the recommendation for batch load as well as the streaming load?
Okay, yeah, this is a really great question. And I'll also let Sudha jump in as well and Sunil. But for my case, it's better to start with in line with the ingestion. If you're getting started, it's the most easiest way to get started. But if you're running like multiple services and stuff, let's say if you're running clustering, cleaning, and all these other things, depending on how you're architecting your lakehouse, you might want to move it to an asynchronous job in that sense. And if you're using like batch or streaming, it really matters in which table type you're using, whether it's a COW or MR tables, and what kind of latencies that is acceptable for you. But I'll also pass it to Sudha and Sunil with their experiences as well.
Arun, the question about the table services is just like the cleaning and the compaction, or are you thinking about other services as well?
It's mostly the cleaning and the clustering, basically, because we tried as part of a POCs for our batching jobs using the inline clustering and the cleaning. But for some cases it was fine, but some cases we do see it actually prolonged the ingest time. So meaning still struggling, like what is the best approach? And also
Correct.
meaning it also goes with the streaming approaches as well.
Makes sense. So inline is mostly like all the things are done serially after the regular ingestion, right? So it adds on to your like the ingestion latency. If you're concerned about the ingestion latency, then the best approach is to do the async. That is also part of the ingestion job itself. Like these services are started async along with the ingestion job. So that is what we recommend to start with. It's easier to get going with that. And if your use case is like sensitive, you have other things in plate that you need to consider a separate job, that is also possible for a lot of these cleaning services. I'll be happy to point you to the documentation on offline services as well. Then when we talk about offline services, we'll also have to talk about how treat them as like concurrent jobs. So we can help you through that should you choose that option.
Well, thanks, Sudha. So meaning how does this play out for streaming scenario?
It's the same. So for MOR, you can make these services run async.
Yeah.
I think that's the default as well. I can check back on the docs for that. But so it's so when you run it as async services, it's scheduled along with the ingest job. So you don't have to worry about manually triggering these jobs in a separate Spark job. That's how it's being designed. So have you tried that already, or is there like did you hit any issues with that? What is your current state?
Yeah, so meaning for streaming we haven't tried, but we did try the async job with inline ingestion. Though as you said, like it runs concurrently. It helps to reduce the job time, but still there are cases we do see, particularly cleaning being done at the very last. Generally takes more time, even if you perform async with inline ingestion.
Got you. We can take up your case. Like what we would like to see is like how your cleaning frequency is, like what is your frequency of writing data and things like that, and see if there is any scope for improvement. And we can follow up on Slack.
Yeah. So
Sure, yeah.
on Slack, go ahead and post like what you're seeing in any snapshots. If you have like there's a delay in cleaning, and then post like your configs, the version of Hudi you're using, the writer you're using, and things like this. And then we can help triage it. And then if we need to move it to a GitHub issue, we can do that as well.
Yeah, sure, Naren, yeah. Thanks.
So there is a question about how is inline clustering different from auto file sizing? How do I choose between those options? So inline clustering there's inline and asynchronously deployment model. So it's just how these services are deployed. Clustering, part of clustering, and Sudhi can jump in, or Samil, implements a file sizing as well. And there's also separately, like you can auto file size when you ingest data where you may not want to cluster data. How do you choose between those two options? It depends on, with clustering, if you want to file size and also improve, like not affect your ingestion, and also improve query performance, because you can help with the data layout as well. That's what the clustering service does. File sizing just helps make sure you don't have those small files, so you can configure file sizes. For example, I believe the default value is like 120 megs. So it just depends on potentially like the query pattern you're running and things like that.
Yeah, I can add. So the file sizing, it's been there since the Hudi's initial versions. What it tries to do is, like, at the time of ingestion, it tries to bin pack, small, like the new writes into small, already existing small files. So as the name suggests, it's just the file sizing service. Like it'll try to do best effort to pack things together. So over time, you will see that the file sizes are like more larger instead of smaller files. Clustering goes above and beyond that. You can also do other things with clustering, like sorting your data based on certain keys, and also like file sizing can also be done with clustering. So if you're looking, if you don't have a use case for sorting, and if you're good with the automated file sizing already, then like you don't have to explore the clustering option. But if you think that you need clustering for other performance optimizations, then that's where you would also look into sizing at the time of sorting and writing.
Yeah.
Does that help?
We have one more question, and the question is, how is inline clustering different from auto file sizing?
Oh, we just answered that. We just answered it. Yeah. So the other question is a follow-up on clustering. How does sorting the columns will help in query performance? So with sorting the columns, you sort the columns based on how related the data is, right, Sudha, in that sense. And so when you run
Right. So
run your queries, and it's easier to access the data, and you get the results a lot faster.
Correct. So let's say you have like a partitioned table, and the partition is based on like in this case for trips, let's say if the partition is based on the trip creation date. And let's say when you're querying, you are actually like querying, and like you have a different pattern of queries where you want to query based on cities or something like that, right? So now within a single date, and you want to query based on city as a filter, and you see this often, what will happen is the data is all over the partition, right? Like since the data is not sorted by query, you will pretty much see like all cities in all files in worst case. And so if you want to optimize the performance in this case, then you can also leverage clustering to sort your like partition based on city ID as well. That way what happens is, like, instead of all files having all the cities, you have like few files for a city, and that can be leveraged in the query performance, since push down filters use that to like prune the search based only a few files instead of scanning all files in that partition.
So the one follow-up question. So where does Hudi indexing come into play here, either during ingest or during consumption?
Right. So Hudi indexing mainly is used for so indexing is a way for Hudi to kind of map where the records are located. So this is used for faster updates. Like, for example, Hudi needs to know based on the incoming records, like which of these records are already seen, or which of these are new inserts, right? And it like, without knowing that kind of an without that knowledge, like to process the updates, Hudi has to, like any system for that matter, without that kind of an indexing knowledge, it will have to scan all the files in the table to kind of know whether to process the updates, right? So that's where indexing comes into picture. Hudi is able to use the indexing mechanism to locate the records, and it also maintains consistently the location, like the mapping of these records. Like, for example, this ties back to the file group and things like that, file group and concepts like that, where Hudi maintains this mapping of record key to file group. So anytime a new update comes, it always writes to the same file group.
And so there are a couple, I think it's worth mentioning, and as like a TLDR asterisk, there are multiple indexing methods that you can use. Hudi automatically employs a Bloom index, but there's bucket index, simple index, and so on and so forth. And depending on your use case and latency, how you're partitioning data and things like this, you can pick one. I can share a blog that I wrote on that. There's also separately, like in the indexing, there's the metadata table. Metadata table also employs different indexes, like file index, call stats, and then Bloom index as well. And that's also available. I won't go into the differences between each, but I think it's just worth mentioning that Hudi does provide extensive indexing methods to choose depending on your use case.
So basically, you mean to say like index exists for both metadata as well as the actual data files. Is it right?
So yeah, there is the metadata table, which is essentially like a central view of all the files. So when you, for example, the Bloom index is employed at the footer of the Parquet file. So if you're not using the metadata table, let's say you don't have that enabled, you would have to open and close each file to check the Bloom index to see whether a record exists in that file or not. But if you use the metadata table, you kind of avoid this opening and closing files, and then you can just refer to the metadata table to grab the Bloom index and then update the file. It's a lot faster in essence because it's a central view of what's in the table.
Yeah, I think his to add to what Nadine said, and also what Arun asked. So the metadata table also is a Hudi table by itself. So that also uses the indexing layer. So we have the indexing for both the Hudi table and the metadata table, which is internally a Hudi table too.
Yep.
And just to add to that, you can build a multimodal index as well for your queries, basically.
There's a question on how can we get, oh, there is another question. What is the high volume of data processed and stored with the help of Hudi framework? Please provide some insight. When you say what is the high volume of data processed and stored, are you talking about throughput or are you talking about which table type to use? Can you elaborate? Vignesh, you feel free to unmute yourself if you want to elaborate a little bit on this question. I think I want to make sure I understand the question correctly.
Hi. So I just wanted to understand, like, with the help of Hudi, like, what is the highest volume of data, let's say amount of volume, right? So let's say in GB or TB, right? Particular table. So I just want to understand the high level.
So you're talking about like throughput? Is that the question?
Yeah.
I'll defer this to Sudha since she's run it in production and stuff.
Yeah, so it's a broad question, but at least we have like major companies using Hudi. At least like from Uber, I know like we even by end of 2018, 2019, when I left the company, that we were running petabyte scale data using Hudi. Most of the data analytics was running on top of Hudi. So like all the raw data was on Hudi already.
I just wanted to add to that. I have done a case study where I've taken Fortune 400 companies and, for example, Walmart, Robinhood, Uber, and their success story. I'm going to leave that link in the chat, so feel free to read them.
I think there was
Yeah, that would be good.
I think there was also, Sudha, there was a good case study that, was it Walmart did or why they chose Hudi? I forgot that, but I can find that.
Yes.
Yeah. We should share that as well. I'll see if I can find it.
All these are linked in the blog site, in like the Hudi website. I'll be able to grab them in the chat here.
Yes. Okay, so we're gonna take maybe a 5-minute break. If you guys want to come back around maybe 9:15, so maybe just a little bit more than 5 minutes, we'll take like a 6, 7, 8-minute break, 9-minute break. And then we'll come back at 9:15 and we'll get started with the hands-on workshop. And if you guys have more questions as we're doing the workshop, configs, things like this is also a great time to bring that. Again, it's a very interactive session. You guys are asking really wonderful questions, so please keep them coming. So while he's pasting the link, I'm gonna go through. We already kind of did the overview of the workshop, and Samil did a great job of talking about what we'll be doing. So I'll kind of skip the intro since that's already been covered in the slides. And we're actually gonna get started with step 1. So this workshop should be foolproof, as we've taken a lot of step-by-step instructions and made sure that you guys are successful in this, and we're going to walk you through all of it. So I'm going to wait for the link and then should be good to go.
Okay, so there's the link.
Okay, so let me go ahead and pull that up. So you guys, we're gonna take this together. So if you pull up the link that Jagan's shared, you can going to accept the terms and login. So go ahead and click on that. And then you're going to click on email, one-time password, or OTP. And then you're going to get a passcode. You're going to paste the passcode in this email. So I'm going to stop sharing my screen, open up my email, and then get the passcode and then paste it into the box.
And the email might also end up in a spam box. So please check your spam as well in case.
Yeah, let me check my spam too. Huh. I think, oh, wait. I didn't put my email in. Okay. All right. So it should be a one-time passcode. You paste that in, and you sign in. Okay, so I'll go back to sharing my screen. There we go. So is everybody at this part with the team dashboards? Let me see. Samil, I can't.
Your hand, so that way we know you are on this page.
Okay, participants, chats. Okay, great. Cool. So it's really hard to get a sense because I can't see anyone, but hopefully you guys are following. So the next thing we're going to do is you're going to click on the AWS console. Or actually, and you're going to open up the console. And it should bring you up to the console home. And so now what we're going to do is we're going to create a user. So you're going to navigate to the IAM service. And you're going to, under access management, you're going to create on users. And if you guys fall behind at any part of the workshop, just raise your hand so we can put you in a breakout room and then we can catch you up. So it's not a big deal. So you're going to go to users and then you're going to click on add user. The username, you can just say admin role or something like that. And then you're going to say provide user access to AWS management console. You're going to click that box. Users must create a new password at next sign in. We can just unclick that for now. And then you're going to click on next. And then on the add user to group, you can go ahead. I think we can skip this part. You can just click on next. Actually, let's go back. We can do probably attach policies directly. You're going to click on the attach policies directly. And then you're going to click on, on the search bar, you're going to type in admin. And then you're just going to click the first thing that you see, which is administrative access. And then you're going to click on next. And then you're going to go ahead and create the user. And now if you go to return to users list, oh, you haven't, you can go ahead and download the CSV file. So now if you go under users, you should see an admin role. You're going to go under security credentials. And then under security credentials, you're going to go ahead and create an access key. And then you can go ahead and use the command line interface and click on next. Oh, make sure you confirm it and then click on next. You don't need a tag. We can just skip that part and then you can create an access key. Now this access key is what we're going to be using in the next step. So if you guys have questions up until this point, feel free to ask them. I'll take a pause here because everyone needs to get to this point before we move on. So if you're at this point, please let me know with a sign of emoji. Arun, I see your raised hand. Do you have a question? Arunka Ramsey, Simi.
Actually, it was raised earlier actually to just.
Which one? What was your question?
No, it was raised earlier to just indicate that I was available. So I forgot to.
Oh, okay, got it. So did everyone get an access key?
Saurabh is still waiting. He's still doing it, so he might need a little more time.
Okay, okay, got it. I see that. I will wait a few more minutes. Let us know when you're there, Subaru. John Weaver says he's caught up. I miss all the details for the user account creation. So on the account creation, we actually didn't document it because this is really just specific to this environment. But let me go ahead. These credentials are going to be tear down anyways. So let me go ahead and just copy all of this really quick into a separate file, and then I'll come back to it in a moment. So give me 1 second and I'll show you what we need to do. So this is I'm just gonna keep track of these credentials really quick. Okay, so I've copied that. So I also missed, we just need to create an IAM user, right? So yeah, let's go back. You're gonna go to IAM user, and under access management, you're gonna go under users. You're gonna click on users. You're gonna click on add user. You're gonna create a username. So we'll do role 2. Click on next. You're going to attach policies directly. Under permission policies, you're going to type in admin, and you're going to click the first box you see. After that, you're going to go ahead and click next at the bottom right. And then you're going to review and create it, and then you're going to create your user. So now I have role 2 that I'm demoing with you guys. So under role 2, you're going to navigate to the security credentials tab. And then you're going to click on create access key. You're going to hit the command line interface for the use case. And then you're going to confirm that you understand. And then you're going to go click on next. You don't need to create a tag. We can skip that. And then at this section, you can copy these keys because we're going to use them in the next section. Are you guys all caught up now? Great. Subaru, Vikul. All right. Cool. I think we are good to kind of move on. So the next thing we're gonna do is we're gonna yep, caught up. Great. So the next thing we're gonna do is we're gonna create an S3 bucket. So you're gonna go under S3 service, and you're gonna click on the S3 bucket. And this is where all the data from the raw tables, silver tables, and stuff will be stored, and all the metadata as well. So you're gonna go ahead and click create bucket, and we're actually gonna use this bucket as part of our environmental document as well. But on the bucket, you're gonna, if you go on this drop down over here, you're gonna see your account ID. Go ahead and copy the account ID. And if we go to the S3 section over here, you're gonna name the buckets. What did I name it? You're gonna name it. It's inside the thing, and I can type it in here at the thing. You're gonna name it this, and under write your account number ID US East 1, and then with your account ID, go ahead and replace it with the account ID that we copied. So if I go under the S3 bucket, I can just paste that here, and then I'm just gonna copy my account ID, and I'm just gonna replace it in this variable that I have here, like that. And you also want to make sure you're under US East 1. I think we should be, yeah, I think we should be good. And then region is US East 1, and then everything else should be fine. And then you can go ahead and create the bucket. And now we have the bucket. It should be empty right now. We haven't done anything yet, but later on there'll be some data in there. And then after this section, we're going to navigate now to Cloud9. So Cloud9 is kind of like an IDE, a cloud IDE, if you will. So that's what we'll kind of do. So we're going to go ahead and after you navigate to Cloud9, you're going to go ahead and create the environment. And in the Cloud9 environment, we're going to go ahead and give it a name. The name that I put is this. I'm going to copy that and then paste that over here as well. You can go ahead and name that. So I'm going to go ahead and copy the name. And then all the default settings are fine. And so we can just click on create. And this probably will take a while to create. If you look at this blue box here, it's creating it. So we'll give it a minute to create it. So yeah, this portion takes a few minutes. If you guys have questions, feel free to ask them as we go through this. There's going to be some dead time.
Can you give a brief overview on what exactly we are trying to set up before we actually start creating tables or anything?
Yeah, this is just a Cloud9 is just an IDE. So it's just like, think of it as a command line terminal thing where you can run, execute, you can run commands and things like that. So instead of me working through your computer and everyone has different computers and setups and operation systems, this is just a way to standardize the environment, basically. It works just like an IDE. I'll show you what
This code, maybe just a VS Code or IntelliJ, that in a simple way, you know.
Okay, and it's connected to AWS directly.
You're right.
Yeah.
Okay. Makes sense.
So if you look at this IDE, you'll see that there's like the tab, like it kind of just looks like VS Code, and then you have your command line at the bottom where you can type stuff. So if we go to the workshop, I kind of made it super handy already. So the first thing we're going to do is this portion, we're going to launch the CloudFormation stack. So what I want you to do is I want you to go through step 5, but I'll paste the commands here as well. And I want you to clone this repo over here. So if I go under here, we're first going to clone the repo. This is where all the code basically exists for this workshop. And if you clone it, you'll see it show up over here now as part of the dropdown. The next thing I want you to do is I want you to go to the gear under AWS Hudi right here. There's a gear. I want you to click the box that says show hidden files. Do we permission restriction for the server located in North Virginia? Sorry, go ahead and ask your question. Suji?
Yeah, so I am having issue creating an environment in Cloud9 for like other server locations. Let's say Asia Pacific.
Okay, let me stop my screen share really quick. So all we have done now is just clone the repo. Sumil, do you want to do a breakout session with Sujit? Oh, Sumil, you're muted.
Oh yeah, I'm gonna add him in the breakout room now. Let me see.
Okay, I'll let you do that. Okay, I'm gonna admit, it says waiting room. Hold on.
Could you add me on the breakout?
No, let me create some breakout rooms. Hold on. Okay. Oh, nope. Let me get out of that. Uh-oh. Is everyone still here? Okay. Breakout rooms. Hold on. It's putting everyone in a breakout room and I didn't want to do that. Hold on. Okay, let me go ahead and It says Vinish is in the waiting room. Yeah, I don't know why the breakout rooms are not working. Okay, so Sujit, do you want to go ahead and share your screen really quick, and I can help debug really quickly? Sujit, are you there?
Yeah, I think it has been disabled. I can't.
Okay. 1 second. Let me just go ahead and make you a co-host really quick. Maybe you can share now. Can you share your screen?
Yeah. Hold on. Yeah. Can you see it?
Yeah, I think instead of Mumbai, I think the issue is
Yeah,
Mumbai.
the region.
Yeah, can you just change it to
US
North
East
Virginia?
Yeah, that was the question I was asking.
Yeah, choose the US East one, and then you should be able to create all the resources here.
Yeah. So
Okay.
I typed the name of how you should name the bucket and everything. So go ahead and do it, because we're gonna wait for you so you can catch up. So just name it this. I typed it into you in your private chat. I'll just put it in a meeting group chat. Check your private chat. I'll paste it here again as well.
Yeah, for any resources that you're creating, these accounts are actually, the resources are enabled only in US East 1. So just make sure that when you're creating other resources, as we follow along, it's all in North Virginia.
And then scroll down. No, just everything is the same. Scroll down to the bottom and then just click next or create. Yeah, create. Click on create at the bottom right. Bottom right.
The orange button.
Orange box.
Yeah.
And now it's gonna take a minute to create. So you can see on the blue box, it's creating it. Once it's created, you can open the box. You can open the IDE.
Okay. Thank you.
So we'll stay here because we're gonna wait for you so you can catch up. Nope, put back your screen share. Yeah.
Okay.
Well, because we're gonna wait for you anyway. So we're gonna make sure you catch up.
Uday, you have to select the US East 1 for the buckets as well.
Yeah, we'll check that later. Make sure he created that. Okay, so it's successfully created. Click on open. Yep. He says someone just said, just curious, how often are these workshops done? This is our first one.
Yeah, this is our first workshop.
Yeah, so if you after the workshop, if you guys had feedback on other workshops you'd like, maybe you'd like a deep dive in clustering, a deep dive on the timeline, we can host these mini sessions as well if you guys are enjoying this. So on this tab now, you're gonna type in, you're gonna clone a repo. This is where all the code exists in the repo right now. So I'm gonna paste that in the thing and copy that and paste that in the terminal. So check the message box, git clone, and then the repo. Go ahead and put that there. Yep. Okay, now you're caught up. Go to, I think everything should be fine. Okay, so now you can stop your screen share and I'll screen share mine. You're caught up. So now we're all in the same spot. Okay. I think this is right. All right, do you guys see my screen? Hold on, I'm gonna move this.
Yes.
Okay, cool. So now what we're gonna do is that we're gonna actually, we're gonna move into the infrastructure directory. So you're just gonna type in, I'll paste it in the box here, hold on, where's the chat? Oh no, I lost you guys' chat.
I can post that.
Yeah, hold on. Oh, I know why, because I stopped screen share. Okay, here we go. So now we're gonna CD into the infrastructure code. And now if you list, You'll see all the hidden files and stuff. Now, the other thing, Sujit, I wanted you to do is go under the gear and then click on show hidden files. So now if we go to infrastructure, you'll see the .env file, and it's just easier to access unless you like to use Vim, which you can do that as well. But now with the IAM user we created, right? When we went to the IAM service, go ahead and press the access key, type in the secret key, type in the bucket, delete this bucket name, type in the bucket that we created on, I'm unable to copy anything from the chat. Oh, okay, Tom, it's also in the workshop as well. So we're in step 5 of the workshop. Can you copy from there?
Yeah, I should be able to do that. Thanks.
Yep, it's in step 5 under Cloud9. And then I did it the Vim way, but if you guys want to use the hidden files, you can just open it up on the UI and type that in. So we have
created a couple of keys.
Oh no, just use admin. The role 2 was for the 2 individuals that were running a little behind. Just use the admin one. Actually, you can use both. Just pick one because they're all the same permissions anyways. Yeah, it was just for a demo to catch them up more or less.
Yeah, thank you.
Yeah. So you're gonna just delete the X's and you're gonna put them in between the quotes. And then your region is US East 1. The bucket name is going to be the bucket name you created. So if I'm going to open up the console again on a new window. Oh, that didn't work. Never mind. Let's go here. Uh-oh. What's going on here? Oh no, I got signed out of my account. I don't know why. Oh no.
It's just timed out. You can let me send you the link again.
Okay. Yeah, I got signed out. Darn it. Okay. I think I might have to redo everything again. Samil, do you want to pick it up? Because I'm going to try to catch up. I might have to redo everything. Oh, you're muted.
Oh, sorry about that.
Yeah.
Everybody see the screen now?
Yeah. Hold on. I got signed out. Yeah, I see your screen. Let me see if I need to get started again. I think I might. Oh, hold on. Let me go to Cloud9. Let me go to S3 really quick. Oh, cool. No, I didn't lose my stuff.
All right, I'll share my screen now.
Yeah, I got it. Let me share my screen. Okay, so under the bucket, you're going to copy the bucket name. And then when we go to Cloud9, you can type it under the thing. I think I might have to redo some of that. Oh, it saved it. Nice. So you're going to put in between the quotes under the bucket name, the bucket that we created. And then under email, just put your email address. Let's put Nadine at onehouse.ai. And then you're going to go ahead and save it. And then you should see an X when you save it. And I think everything else looks good. I don't, Sumil, I'll let you and Sudhab monitor the chat because I'm not seeing it right now. And if you guys, okay.
I'll take care of the chats.
So the next thing we're going to do is if we go back to the workshop, you're going to go ahead and save the file, and then you're going to run on step 9. You're going to run these commands individually. So you're going to go npm install -g serverless.
I'm going to send these commands in the chat as well. So
Okay.
anyone.
Yeah. So if I go back to Cloud9, there we go. I'm going to type, I'm going to type it in the terminal, and then this is going to be some dead time too. And so we're going to type in. So the next part is the credential part. you're going to replace the access key and the secret key with the access and secret keys that we put in the env file. So just copy and paste the second line into like a text box and replace the keys, and then put it back into, type it in the Cloud9 terminal. So that's what I'm doing right now. And you can delete the brackets too. So you just want the keys themselves. So it should look something like this.
So there's a question, what is serverless framework? What are the benefits of using it? So it is similar to CloudFormation template. It allows you to create resources. So we are creating DynamoDB, Lambda functions, glue job. So it helps to deploy the resources basically.
Yeah, so in CloudFormation, typically you'll have like a YAML file or something that you'll deploy to launch the resources automatically. In the workshop, instead of me asking you to like create a DynamoDB table with 4 tables, that create an, you know, your glue databases and your glue ETL jobs, things like this, we're automatically have it all set and we're just going to deploy it. So we're going to talk to CloudFormation. CloudFormation is going to create the resources, and then we'll show you what those resources look like. And then now we're going to plug the .env plugin, so npx serverless plugin install. And then this is the example of what your credentials should look like. So you just want to put the keys after the command. And then I'm going to deploy the plugin. And then we're going to deploy the Python requirements. And just paste those one by one. Compare to CFN. What is the access key in the file? The access key is the key that we got from the IAM user when we first created it. Does that answer your question, Shudi? So I'm installing the Python requirements. And then I'm going to do the plugin install serverless glue. Next. And then we're going to do, after that, we're going to deploy it and we're going to talk to CloudFormation. CloudFormation will create the resources. This part takes like 3 to 5 minutes. So we can hang tight here. So if you guys have questions, now is a good time to ask them. So we're going to have some dead time here. Feel free to unmute yourselves because we're going to have like a few minutes here.
Yes, I do have a question here. So basically the serverless templates which we are using here is just for the demo purpose, right? I mean, if we go into the real world scenario, we won't be creating DynamoDB and all those stuffs using serverless.
Actually, you can. Like right now we've already pre-planned. So I think the idea is like conception, and Sunil, feel free to jump in. Like in this case, we know what the architecture looks like. And for the purposes of workshop, we're deploying it, we're creating these resources. But if you're like building something you're not too sure, you'll build them manually in AWS. So you'll go to DynamoDB, create table, add some data, and prototype that way. We've kind of done this all already. So now what we're doing is we're just setting up the resources.
That is correct. So when you're developing something new, you can create through a console. And then when you want to deploy it to production, you would create all these resource object and you would deploy that through a CI/CD pipeline.
Yeah, exactly.
Got it.
But when you're prototyping, I don't think you'll be doing this unless, you know, you already know what you want to do. Harshwanan, do you have a question? Feel free to unmute yourself.
Yes, thanks. Actually, I have a question related to metadata. I think somebody has answered that. If we enable the metadata in Hudi, then we'll be able to access the table itself. But I just wanted to understand, is Hudi going to create that table in the respective data catalog that we'll be selecting? For example, if it's a Glue catalog or Hive, is that the way we can access that metadata table? Or as it is going to create some metadata files on S3, is there a way to access those files through Athena or maybe some other tool?
I can probably answer some of it. So Hudi offers stored procedures, and you can use those stored procedure in Spark SQL to see the metadata. And of course, Hudi also offers Hudi CLI. You can use Hudi CLI to see the metadata as well.
Okay. Okay. Thank you. Thank you. Yeah. Thank you so much.
You can see that this deployment process takes a while. So actually it's a fun project. If you go to CloudFormation and you want to check it out, you should see it starting. You can see that it's like getting created and stuff. So so now this is how we're talking to CloudFormation through the deployment.
Can we get some thumbs up if you are along with Nadine on this step? Perfect, perfect.
Cool. And I think Jongath, are you still here?
Yes, Nadine.
Yes,
I'm
he's
still-
here.
Yeah. So if you guys have any AWS questions as well, Jongath is here to help with that as if you guys want to ask questions around that.
I have a question from the the bucket perspective. I think Swamil has already mentioned in his one of the examples of what we are doing here. I think we are following the medallion architecture.
Yeah.
Correct. Yes.
Yeah.
How is the structure formed over there? Because I always thought that the medallion architecture is the naming conventions which is being used for the raw tables or the transform tables. But in the real scenario, when we talk about medallion architecture, how is it shown in the S3? How can we use that as a concept? Yeah, that was my question.
When you say use, can you elaborate more?
I mean, like, how can we form that, the medallion architecture?
That's the whole purpose of this workshop. We're going to show you how we're doing it. That is literally what we're building. So right now, if you go to S3, there's no tables. It's empty.
Yep,
but we're going to
Yeah.
insert data into DynamoDB. And then Lambda, we're going to use CDC. So we have Lambda code that is going to register the event, and it's going to create the raw table. So the raw table is literally just that. We're just deserializing DynamoDB JSON data, and we're going to add it to the raw table. That's it. It's not clean. There's nothing else on it. It's just a whole bunch of Parquet files, literally. Now, in the silver portion, what we're going to do is we're going to create a glue ETL job. Let's go back to the architecture actually while we're waiting for this. Let me go back to the introduction. I'll zoom in. So the CDC streams are going to create the there's a Lambda code that registers the event. And then we have code. We'll go over the code, but it just basically deserializes the data and adds it. Now on this section, we're going to run an ETL pipeline. And what we're going to do is we're going to create a glue job where we're adding, we're going to supercharge our S3 bucket with Hudi. Early in the presentation, I said, Hudi is basically a lakehouse platform that gives your data lake superhero capabilities. So you're going to be able to manage the data, clean the data, and things like this. And this is where we create these different tables. We have the rights table, the date dimension table. We're going to create these silver tables. And then what we're going to do is we're going to run another glue job, an incremental ETL, where we're going to create this driver's earning table. Now, let's say if you have, and this driver's earning table is like, basically think of it as like an aggregation and joining of these different tables. So this is like this part is a lot of SQL code that we're writing to create this earnings table. So this is what we call like the business layer or business analytics layer, where you create this gold layer and then you can use analytics to clean this. This is like the most clean data that you'll have. But in order to build this table, we're going to do a lot of complex data, like SQL code to write this and some other code, and then create this driver's earnings table. And we'll show you what this looks like when we get to these sections. And at the end, we're going to query this business level table with Athena, and then we're going to use Quicksight to visualize it. Does this help?
Yes, makes sense. Yeah.
Yeah. And then this pink icon is SNS. So anytime there's a failure, that's why we wrote the email in the .env file. We'll get a notification from AWS that something has failed.
Understood.
So that's what these pink boxes are. It's like a monitoring in essence. You can use CloudWatch logs and things like that. But if you want to get a notification and you're running big pipelines in prod, you'll probably definitely want an email.
Makes sense. If the deployment is not yet complete, I have one more question.
Yeah, go for it.
Sure, go for it.
Yeah. Okay, so basically in Hudi, for every table we create, we need to have a primary key, right? So is there any option in the near future where we don't specify a primary key and we still create a Hudi table? I know the primary key is basically to have, the update or the access which we perform.
Yeah.
But every table will have that, concept of primary key.
Yes, it's correct.
So,
This is correct.
yeah.
But
How do you handle that?
What do you mean handle?
I mean, like, I don't want to create I just want to create a Hudi table without a primary key.
You can't do that now. There is something in RFC that we're creating, working towards a primary key list type of entry. But it's not available now. It's something that we're thinking about. But right now, you have to set a primary key in order to create
Is it something like the auto increment functionality which might kick in the near future or something?
That's correct. Yeah.
Okay, got it.
And then there's like a key generator. If you go to the Hudi website, you can create the key generator. Yeah, you can use that. But as of right now, but there is something in the line for primary key list entry for your records, but it's not available. Okay.
Thank you.
So
one of our members have an error, and maybe he can share a screen. Prashant.
Yeah. Let me stop sharing. Prashant, do you want to share your screen? We can debug pretty fast. Prashant?
I think you might have to give him access, Nadine, to share the screen. I can give him access.
Yeah, feel free to make him a co-host.
I think I do not have access. Sudha, do you have access to make him as a co-host?
Okay, let me go through the participants. Hold on. I can do it right now. Hold on. Prashant, can you hear us? Is it Prashant D? Is that
Prashant Bhav, sir?
Yeah, this looks right. So yeah. If it says 6
yes, that looks correct.
Thanks.
Okay, it says we're on validate resources step. Yeah, we're on the validate resources. Prashant BHA. See me PRASH. Okay. Make co-host. Can you share your screen, Prashant? I just made you a co-host. Sujit, do you have your hands up? Hashwan, do you have your hands up? Feel free to ask your questions. Who's sharing their screen now?
I guess it is Prashant. Prashant, can you hear us?
I can't hear you, Prashant. Arun, go ahead and you can ask your question.
Yeah, so from the bronze layer to the silver layer, do we do some kind of transformation, or all the transformation will be slated only for the gold layer?
I can probably answer that question. So the question is, are we doing any transformation? The answer is no. We are simply going to dedupe the data using Hudi's pre-com key. And that way, that would be our silver zone. And from there, we're going to have incremental pipelines. And that's when we're going to do all the transformation.
Okay. Sure. So the transformation will all be done only on the gold layer.
That is correct. Yes, Arun.
Prashant, I just see your screen thing.
Just a quick follow-up. Saumil, you said something about decomp key. Can you briefly talk about that?
So we are going to cover that shortly, but just to give you a little bit high level, a pre-com key in Apache Hudi is used to dedupe the data. So when you have, let's say, record ID 1 and you have like 3 items, you can use the pre-com key to select the max of that and essentially helps you to dedupe the data.
Yeah.
But we're going to cover more soon.
Yeah. So when we went to the presentation, we talked about Hudi has built-in table service, like built-in features and services. One of them was deduplication of data. That's because of the pre-comp key. It's part of that built-in thing. So you don't have to dedupe, you just type, the pre-comp key and it takes care of that. Okay, so Prachand, I'm having trouble hearing you. So if you are able to speak, let me know, or I'm just going to go ahead and move through the workshop right now. So now if we,
I have a
oh, go ahead.
I have a quick question. So this Cloud9 environment, like this is like a playground for testing and
Yeah, it's
building stuff.
yeah, it's just an IDE. So instead of me navigating through each of the operating systems and what your personal configurations are, this is just a standardized like IDE, like development environment where you can make HTTP requests and things like this, and I don't have to worry about each individual's computer setup. That's all it is.
So we are going to build the like bronze to gold layer structure using this CLI, right?
Yeah, so right now we're going to build the raw layer. We're going to insert data into DynamoDB, and then we're going to create a raw layer of just raw data full of Parquet files, basically.
So is this like a standard format?
Yeah, usually you'll create a raw layer of data in the medallion architecture.
No, I was talking about this environment thing. So like if we have to test something, do we have to like always use Cloud9 in AWS?
Oh,
like,
no, you can use your own IDE. So AWS has a command line tool, Photo 3 and stuff, that you can use to talk to different AWS services. But in my case, because I'm hosting a workshop and people have different computers and versions and setups, I just didn't want to take 3 hours to troubleshoot people's errors. So that's why we're using a cloud environment for the IDE. But you can use your own computer, set up the command line interface and things like that. I can send you the link to how to set that up, but you can directly talk to, if you have your access key, secret keys and all that, you can create AWS services and everything through your own computer without using Cloud9. Does that answer the question?
Yeah.
Okay. So now if we go to S3, well, actually, let's go to DynamoDB. We're going to verify the resources really quick. And if you go to tables, you'll see that there's a drivers, rides, tips, users. So that's good. And then, and if you go to glue and you go to ETL jobs, you'll see all the ETL jobs that we have that we'll be using. And if you go to data catalog under databases, you'll see we'll have a rides DB database. And all of that should be empty because we haven't done anything yet. So these are the resources that we've launched. The other thing that we've launched is the Lambda. So if you go to type in the Lambda service and you go to functions, you can see all the functions that we have here. And this Lambda is basically used, if we go back to the workshop, that whenever data is inserted, we're going to use CDC streams to populate a raw data layer, a raw bucket for S3. But the conversion from like the DynamoDB JSON, deserializing it and putting in here, this is actually the Lambda functions that we'll be using. So that's the purpose of it. Okay, so now the next part, we're in workshop part 2, where we're going to ingest data into DynamoDB. So assuming you have writers and all these things, and as your trips complete, you want to send them to a database. In this case, we'll be using DynamoDB. So if we go to back to Cloud9 and you go to ingest code, so you'll see there's a folder called ingest code, and you'll see that there's actually just navigate there through the command line interface. So if I'm under the infrastructure code and I hit PWD, I'm just going to navigate back really quick, and I'm going to move to the ingest code part. So it's just top level, same inline as infrastructure. And then if I list it, you'll see that there's a requirements txt and a run.py. So the first thing we need to do is we need to install all the libraries that we'll be using for the scripts. So Samil, if you want to type in the code in the box.
Yeah, I just did that in the chat box, Nadine.
Yeah, cool. Then I'm going to just type it in here, and we're going to install the libraries that we'll need in order to run this workshop. Just make sure you're under Hudi Rideshare Workshop and then ingest code. And then, did I get an error?
No, it's just a warning. I got this.
Okay. Sounds good. So now that we've installed it, I think now we can actually, we're gonna walk through the code and then we're gonna go through that. So we'll do a quick code walkthrough. So the first half of the code is basically using some libraries, and it's also written over here. So all of the code that we'll be using, all of it is written in what exactly we're doing. But I'll just kind of go through it here. We're just using some libraries and stuff that we'll need. We're using DynamoDB to basically create the database model and talk to DynamoDB and make a put requests and things like that. And then we're also using a faker to create fake generated data. And then on the next set for 24 till like 45 or so, we're generating fake users with some sort of schema or like some sort of key value things about the user. Pretty self-explanatory. Then we're generating fake rides. We're generating some fake tips, hopefully good tips. And then we're also generating some riders over here, and we just have an array of different car models and stuff and riders. So that's all that we're doing here. So we're just generating fake data. Now for the DynamoDB class, we're actually creating some of the model over here. And so that's what this is kind of doing. And so we have the tip model, the driver model, the user model, and then this is the parameters that you can set on how much fake data that you want. So if you want, 1,000 users, you can change this number. If you want, 1,000 tips, or if you want to change the dates, you can. So these parts are all configurable. And then on this part, we're just calling those various functions to generate the fake data. And then we create a connection to DynamoDB. And then we're ingesting data basically. And that's ingesting tips, ingesting users and things like that. And then we call the ingest function to actually write to DynamoDB. So this is what's going on in the code.
Nadine, can you go to line 14? I think we just gotta make a small change on the env all the way up on the imports.
Oh,
The
here?
infrastructure, yeah.
Oh,
No, in the ingest.py and go to run.py.
yeah, this is
up. Yeah, scroll all the way up, please.
Oh.
Here, line number 14, line actually 16, you see infrastructure, the spelling, we changed it to lowercase. So I think
Oh, I see. Okay. And I think, okay, hold on. Infrastructure. STRUCTURE. Okay. Here, just copy this line, guys, for line 16. Do you want to paste that in the thing?
I'm gonna do that, Nadine. Thank you.
So hopefully this is right. NIRASTU. Oh, it's T. I think I spelled that wrong, actually. TRUCTURE. Okay, this is fine. This is right now. So just make sure when you edit the thing, you guys save the file as well. So now we're gonna do run the file. And hopefully there's no errors. Cross your fingers. Oh yeah, it worked. Nice. Okay. Okay, I'm gonna take a pause here, and I want to make sure everyone got the printout of some sort of printout that was successful. If you have the printout, please type it in the chat box, some thumbs up, and then I know I can move on. Okay, 80.
Oh wow, a lot of people got it. Perfect. Great, guys. Thank you.
Can you
Quick
please?
question. No.
Yeah.
Do you have to do any edits on line 199?
No, there should not be any edits except the import function.
Okay.
Yeah, you don't need to do that. This is just going to create, you don't need to worry about this.
Okay.
I'll show you what that looks like later. Okay, can we see more hands up? I see we have, I think, I don't know how many people we have, but I know we have more than 5.
3, 4.
Okay, great. right.
I'm having issue installing the requirements.
Yeah.
Can you
basically
please scroll up the terminal code? No, in the terminal. Yeah. Little bit up. Yeah.
Did you
It's-
use?
Okay,
skip
so
through?
we should just go. Yeah, got it.
Okay. Okay. Okay, cool. And I think we're
When
good.
I am having errors,
Okay, inserting ride.
You have to say Python 3, make sure it is Python 3. So
Try Python 3. I don't know. Here.
yeah, Python 3 space run.py. I'm gonna paste the command in the chat. So that should be the command.
Oh, that worked. Okay, great.
All right, great, thank you. So Python uses the default Python 2, so we have to specify that we are using Python 3.
I didn't do that. Mine worked, but
Well, it works.
it's both ways. Okay, cool. We can move on. Oh, we ingest rides, time args, attribute error, DynamoDB.
Yeah,
Once-
Gaurav, you need to put that import statement. Make sure you correct that import and make sure you do pip3 install requirements.txt.
Yeah. So on line 16, you need to make sure you have this on line 16.
What's the import statement, sir?
Yeah, it's gonna be there's a spelling or typo error on the word infrastructure, and I pasted that in the chat.
Yeah.
So if you could just copy paste and replace that line, that should work.
Yeah. It's just not reading correctly from the right env file. That's why you're probably getting this red error. Amaresh, did that work for you? And Grav?
no, do I need to do a pip install again or?
Yeah, you would do pip3 install requirements. So we are installing all the libraries, and once that is done, then you use the word. Then you would change line number 16, and then you would say Python 3 run.py, and that should fix those errors that you are seeing.
Yeah, I typed it all.
I did do all of them.
Okay, let me stop sharing my screen. Do you want to share your screen really quick?
Yep, 1 sec.
We might have to give him again the host access.
Yeah. All right. Amaresh, go ahead and share your screen.
Yep, I am doing that.
Yeah, we see your screen now.
Okay.
Okay.
Alright.
So infra t ruct.
Could you install requirements.txt first? Can you do clear?
Oh, try running Python 3.
I tried both. So.
Okay, let's see.
Infrastructure seems to be spelled wrong on 16.
It's infrastru. Yeah, CTUR. It looks right to me.
Can you click save, Control S on your keyboard, or if Mac, Command S?
Yep.
Perfect. And then try Python 3 run.py. Yay, works.
Okay,
Perfect.
Okay.
I'm also having issue.
Okay, go ahead and share your screen.
Alright.
Okay, go to line 16, RA.
Yeah.
Oh, there's an okay, hope so there's no space there. Did you
Okay,
install the requirements?
Yeah.
Okay, can you try Python 3 then?
scroll up to the terminal really quick. Oh, wait, security. Did you edit the
Access
put
the secret
the access key? Did you put the right access key in your .env file?
Yeah, that error tells that the access key is incorrect. Probably you might have to fix that in the env.
Yeah.
Yeah.
What access key did you use? Is it the IAM user we created?
Yeah, this one.
No, it was the IAM user that we created.
Okay.
Go back to the IAM profile.
You might have to create it again because you went out. So I'm not sure if it's gonna show you the access key again. So you have to create a new user and then get the keys.
Go to users.
Here in access key, I have to put the username, and the secret key I have to put.
Yeah, but you have to get it from the IAM user. That's why we went through that step in the beginning.
So
So
click
go
on
to users. Yeah. Yeah, you need that did you save that access key? Go to security credentials. Nope. Nav, yep. And then go to the bottom a little bit, click on access keys.
Create access
Yeah,
keys.
create access keys. Nope. Yep, right there, create access keys. Nope, go a little up. A little up, yep, create access key.
Yeah, I think I have this one. This
You
one.
need to, yeah, well, just go ahead and create a new one, just in
Yeah.
case. Just generate a new one. Go ahead and click on create access key. Go to command line interface. And then next, and then I understand, and then next. And then skip it, just create access key.
And now
Okay,
copy these.
now copy this and paste it in your, oh, but then he has to deploy everything again. He has to he
It's
has
fine.
to,
No, that's fine. It should be all right. Don't worry.
he has to redeploy everything.
Yeah. No, he doesn't have to redeploy.
Oh, but the, okay.
Yeah, the lambdas will fail. You're right. So he has to redeploy the
Yeah,
stack.
you have to redeploy. You have to redeploy. Okay, did you save it? Okay, just do
Yeah.
SLS. What is it? SLS deploy. You're gonna have to redeploy it again.
Did you change
Okay.
the env file first?
Yeah, he just did.
Yeah.
All right, type this command in. You're gonna have to redeploy because everything was deployed with those credentials. So now that we've changed it, it's gonna fail. So go ahead
So
and
I have to start from here,
No.
right?
nope.
The
I
last
just the last part. I already put it in the chat
Okay,
box.
this one.
Yep, go back to Cloud9. And then on the terminal, just type in deploy. Just type in that command there.
It's
Yeah.
in the ingest folder. It's not gonna work. Go to the
Yeah,
infrastructure.
go to the infrastructure folder. So navigate one up and then go to the infrastructure folder. So type in cd
So
space ... Nope, take that
I'm
away.
not able to.
No, on the command line, on your
Yeah,
command.
so I'm not able to access the command line. Like I'm not able to see the.
Oh, no, you don't need to. Just get rid of npx SLS deploy. Just delete it. Just hit backspace.
Let me stop sharing the screen on the nav.
Oh no, we can help you. Just delete the npx SLS deploy, like on the command line. You're on the command line, type that in, just delete it.
Yeah, I'm not able to see the bottom part of the command.
Oh, I see. Okay.
Yeah,
Yeah, just
because
go
I'm
back.
sharing the screen.
Oh, okay. Just go back to the infrastructure code under where, yeah, in this environment. Yeah, go back inside here and then type the npx SLS deploy inside that infrastructure folder. And while you redeploy, we'll continue with the workshop and then we'll catch you up.
Sure.
So you can stop sharing now.
For me, the job ran fine, but I didn't see any data on the DynamoDB.
Okay, we're gonna check that right now. So let's go to DynamoDB really quick. So now we're gonna validate the resources. If we go to DynamoDB, and oh, actually, I'm not even sharing my screen. Let me do that. So if we go to tables and you click on dev.drivers and you explore table items, you should see some data populated. Are you saying you're not seeing data populated?
Yeah, I'm not either.
You're not?
No, but it said that it ingested successfully.
Oh, okay. Let's see your screen. It's showing up for me, which is weird.
No, maybe I need to click on the explore. So it scans
Can you try
the table.
refresh? Yeah, just refresh your screen. Press Ctrl+Shift+R on your keyboard. That should do a hard refresh on your browser. Hopefully that should fix.
Yeah, but I could see the data on S3. But after I clicked explore, right, I could have seen DynamoDB. Maybe it needs to scan the entire.
Yeah, might be browser probably. Can you try refreshing that?
Yeah,
Yeah, it works.
feel free to share your screens too so we can debug.
Yeah, no, for me it works fine now. So I could see data and I could see
Okay,
S3.
great.
Perfect.
And John, did you have the same issue too?
Yeah, I did, but I'm looking into it. Just a second.
Yeah, hard refresh and then it should exist.
Oh, I got it. Just use the get live item count if
Yeah.
nothing.
Okay, got it. Okay.
Yeah, or you can just do like once it's there, yeah. So now if we go to S3 and we go to the bucket, you'll see that there, if you go to the US East one, now you'll see that we have all the resources we deployed and we just created the raw table. So this is what we're seeing here for the raw table. So now if we go back to the infrastructure in workshop part 2, now we just created this raw layer by using that. And we use the AWS Lambda to kind of trigger that. So if we go back to, so now we've kind of just done the ingest into DynamoDB. So now we see that. So now we're gonna
Excuse me.
so in the, let's see, I'm gonna skip the CloudWatch. Should we go over the CloudWatch, Camille? You think we have enough time?
We can skip, it's just a log, so probably we can skip.
Yeah, you guys can go through the workshop to check the CloudWatch logs, but if you go under Lambda, because we're triggering these Lambda functions, I think you can go to just pick one of them. And if you go to monitor, I'll just do it since it's just good to debug anyways. If you ever reach issues with Lambda, you can just navigate to the log watch and then you'll see all the, you can just click on some log stream and then you can see the requests coming in and whether or not there's an error. So if you're not sure you're getting an error and you're using Lambda functions, you can use the CloudWatch logs to help with part of the debugging process. And that's all it's saying, that we triggered it, we deserialized the data and things like that.
And for all the participants, there are 2 ways to get data out of DynamoDB. One is the DynamoDB streams, which we are using in the project. You can also use Kinesis stream as well. So I just wanted to, add that as well.
Okay, so now if we navigate back to S3 and we go under the right share with the raw data, and let's just click on, these are the different partitions we have, but I'm just like kind of click whatever you want to click now. But now if we just click this box on some Parquet file, once you navigate down all the partitions and you do actions and then click one of these boxes and then click on actions and then click on query with S3 select. We have Apache Parquet format and we want the output to be a JSON. So just click the output settings as JSON and then you can just quickly check the data and run some select function. We're just going to do a select all or limit 5. And I'm just going to run the SQL query. And now you see the JSON returning back. So this is how we're verifying that the data exists. It's good. This is what we created. And it's a quick and dirty way to just check and validate the data. Any questions here?
Yes, so just want to understand the flow. So whenever there is a new entry in the DynamoDB table,
Yeah.
one record or one file will get created right through that Lambda function. Is that the flow?
Yeah, the Lambda is triggered. So if you go under infrastructure Lambda functions, you'll see there's one Lambda functions for each DynamoDB table we have. The code is pretty much same, but if we want to do a quick run through of this code, we can do that as well. Would that be helpful? So this is the Lambda function. So data is in DynamoDB. Lambda says,
Yeah.
oh, we have data, and then it creates the raw bucket basically in S3.
Yeah.
Should we run through this code or?
No, this is okay. This is fine. This is okay. You just want to understand the flow.
Yeah, so we're just serializing data, creating some daytime objects, and just kind of like create. Just we're not like massaging the data or anything. We're just formatting it and then making it a Parquet file and then sending it to S3. That's all we're doing here. Okay, so this is the end of my section. I am going to pause. Does anyone need a break or are we good to continue to the silver tables?
Do you guys need a 5-minute break or do you want to continue to the next part?
I have one question. So in the Lambda code, like, can you hear me?
Yes, sir.
Yeah, so in the Lambda code, I do see like there are events for insert, modify, and remove. But I just come through the CloudWatch log, but there are only insert events. So, meaning, did we not create the modify or remove events, or why is that? Or we are focusing only on the insert event? Just want to clarify that.
Got it. Yeah, Arun. So we in the ingesting part, we are simply inserting. But if you can update something, you will see those events also flowing into S3. I have removed the the field called inserted, modified, or deleted. But if you need that metadata, you can include that on the payload. Does that answer your question, Arun?
Yeah, sure. Yeah.
Okay, cool. Sumil, I think we're good to continue. We're getting thumbs up, so I'll pass it to you for the silver table.
All right. All right, let me share my screen.
Yeah,
Quick question before
Yes,
me.
go ahead.
So I want to understand, when is this Lambda triggered?
basically anytime there's an event. So we triggered it. There's like this parameter called like events, was like an event. And so anytime there's an event in DynamoDB, that's when it gets triggered. It's like listening to it, and then it performs the various functions, and then it sends the data to the raw table that we created.
Is the Lambda polling the DynamoDB table, or is it a push?
I can answer that question. So DynamoDB streams is a feature which Lambdas can subscribe to the stream. So anytime there are any changes, the Lambda function will be invoked. I'm assuming behind the scene, and probably Jagan would be the best person to answer. Internally, there might be a polling Lambda, which is polling some sort of a queue and getting the data, but I do not have the exact answer to that point.
Yeah.
Probably using Event Bridge.
Yeah, behind the scenes.
Yeah.
I think I can chime in there. So DynamoDB has a feature nowadays that when there is a change, it will automatically create an event, and Lambda is a subscriber for an event. So
Yes.
it's a DynamoDB feature who generate an event for you.
Yeah. That's why if you look in the Lambda code, there's a parameter called event that's listening to that event.
And this is configured via the CloudFormation template we ran earlier.
The serverless, yes, you are right.
Okay, good.
So typically you would write your own Lambda functions. What we did is we already created all these resources for you, and then we deployed it. But if we wanted to do a full day or 2-day workshop, we would write everything by hand. But in this case, we're just running through some of the different parts of it.
All right. Any other questions before we move?
Yes, I do have, like,
go
in the raw table on S3, the table name is given as is equal to and then driver. Is it that the format which is followed over there is for partitions?
Yeah, I can probably answer that. So we are following a Hive style partitioning format. So that is why in Hive style, you have a key and a value. But with that being said, you can simply have the folder as well. There's no need to have a key and value.
Okay.
I am using a Hive style format there.
Got it. Okay.
All right, I guess we can get started now. So hopefully you guys are at this part. Can you guys see my screen first of all?
Yes.
All right, perfect. And let me see if I can put this on the bottom section over here. All right, so going back to the architecture, just want to make sure we are, if I go to the introduction quickly. So we have the data on S3, and now what we are going to do is we're going to utilize Glue and create all these Apache Hudi transactional data lake. And we're going to take a look at the code now. So if you guys can head over to Glue over here, you can click Glue. And then over there, you would have a database, which will be called RightsDB. If you click on the database, you do not have any tables. We are going to create these tables using Glue jobs. So now what I want you to do is head over to ETL jobs over here, click here. And then when you scroll down, here you will see all the ETL jobs that that's going to create Hudi transactional data lakes. So I'm going to show you for one of them, and you can repeat the process for the other tables. So for example, I'm going to take, let's say, users. So we're going to click on that. So first, I'm going to walk you over the UI, right? So here in the job details, here you have the Glue version as 4.0. Glue 4.0, Apache Hudi is supported by natively in Glue 4.0. Language as Python. This is the worker type. AWS offers G1X, G2X, G4, G8, which you can see in G1X, you have 4 vCPU and 16 GB RAM. In G8, you have about 128 GB RAM and 32 vCPU. So you can select the instance type. But for now, for the workshop, I'm keeping it G1X, but you can definitely choose a larger instance. Then over here, AWS Glue also has a functionality where you can automatically scale the number of workers. So if you're unsure and if you don't know how many workers you want to use for the job, you can simply click on automatically scale the number of workers, and AWS behind the scene will basically scale your workers based on your load. But for the demo purposes, I'm using a fixed number of workers. I am requesting 10 workers over here. Okay. Then if we scroll down, let me put this one on the side. Here you will see advanced properties. You want to click there.
Sunil, really
Yes.
quickly, I'm going to move Sujit and me to a breakout room to help.
No
with the-
problem. That's fine.
And I'll come back.
Okay.
Sudha, are
Over-
you still here? Sorry, Sudha, are you still here? Sudha's.
Yes, yes.
Okay, I'm going to move to a breakout room. So if you want to help with the questions and stuff, I'll come back.
Yeah, definitely.
All right. Thank you. So here you can see we are using AWS Glue data catalog. So we're going to catalog the data using AWS Glue data catalog. So I'm enabling that particular checkbox over here. Now, how to use Hudi on Glue? So the way you can do that is through these parameters. So I'm going to show you. You can specify the data lake formats as Hudi, right? Then you provide the configuration. This is the configuration that we are providing. And these are some of the parameters which I'll be walking you over shortly. But I just wanted to walk you over the job details part. And now we can take a look at the code base. So what I'm going to do is I'm going to open up my IntelliJ, and probably I'll open up either any one of them because the code is pretty much same for all of them. All right, so we can start from the top. So here we are defining few imports. We are defining OSS, Bodo3. We are defining, a Spark context. We are importing a Glue context as well. So just some imports over here. Over here, we are creating a Spark session, right? And then over here, we are defining our parameters, right? So these are your placeholders, variables, right? So I'm defining that. Over here, we are creating a Glue context and a Spark session, right? As you can see. And then on a high level, you have three methods: run function, read data from S3, and upsert Hudi table. I will be spending some time talking about the upsert Hudi table, but let's go over what it does. Over here in the run function, as you can see, we are calling a method read data from S3. We pass in the path, or the raw path where the data is. We pass in the format, right? And we pass in the table name, right? So let's see what this function does. This function basically checks if the format is Parquet or JSON. In our data lake, in the raw zone, the data is in the Parquet format, right? And then what we do is basically we create a Glue data frame. So we say Glue context dot create dynamic frame from option. We provide in the connection type as S3 because I'm reading data from S3, right? And then here you can see I'm providing the path. Oops, can I close this? Okay, so yeah, here you can see I'm providing the path and recursive astro, meaning read all the data in that directory, right? And after that, what I do is I convert the Glue data frame into a Spark data frame by using the word to_df. And then I print the data frame on the console and I return the Spark data frame. Now, I wrote a generalized method for upserting data into Hudi, and I'm going to talk about all these parameters in details now. So we can start off here. Again, as you can see, these are very basic settings that we are defining, and we're going to talk about the pre-com key, etc. over here. Here I define the table name, right? I have to give it a table name, right? So this is the table name, right? The table type for the demo, as you know, we are going to use copy on write. So the table type would be copy on write. Operation is upsert. We're going to perform an upsert on a Hudi transactional data lake. Record key is similar to a primary key. We are going to define a record key. Pre-com key is used for dedupe purposes, meaning when you have, let's say, user one multiple times, you can use a pre-com key to dedupe the data. And the way this works is, for example, again, a very simple example that I'm going to take here. So let's say you have a user one, and let's say the date was maybe, let's say, 10/01, right? Then you made some update, and the date was, let's say, 10/02, right? Now you can use the precom key as a datetime attributes, meaning Hudi will always take the max of that. So meaning this record will be taken into consideration when you have duplicates, right? So during ingestion, when you have duplicates in a batch, you can use the Hudi precom key to perform deduplicate, okay? All right, this is the settings for Hive sync. What do I mean by Hive sync? Meaning we are gonna catalog the data, right, in Glue. So these are the settings for that. We are defining the Glue database name. We are defining the Glue table name. We are defining the compression codec as gzip so that I can save some space, right? Hopefully that makes sense. These are the settings for the cleaner, meaning what I'm saying here is, hey, Hudi, keep the latest file version, meaning if you remember from the presentation, anytime an update happens in copy on write, Hudi will create a new base file, right? So what I'm saying here, hey, Hudi, only maintain the latest version. Why? Because I'll save storage cost as well, right? So I'm telling Hudi to keep only the latest version, and we are using a Hudi cleaner utility over here. So that's that. Then partition. So we are partitioning our data. So this is the partition field, which we're gonna see in the job details. So we want to partition our data lake, right? I'm not going to cover the index type. Again, that will be too much, but I'm using the default index as Bloom. Hudi offers other indexes as well. For example, if you require uniqueness across all the partition, you can use global Bloom. But again, this is beyond the scope for the session. This one, I would like to cover that. So file size, again, by default, the file size in Hudi is 120 megabytes, as Nadine explained during the presentation. So what I'm saying here is basically, I'm telling Hudi, hey, Hudi, I want to maintain a file size up to 512 megabyte. So the small size limit, meaning I'm saying any file which is less than 100 megabytes can be eligible. So meaning if I have a diagram here quickly, hopefully if I open up that quickly. Go here, go to the workshop, and hopefully this will explain the file sizing in a nice way. All right, so this explains the Hudi file size in a very nice way. So as you can see, focus your attention towards the left-hand side, okay? Here you can see Hudi Parquet max file size. It says it's set to 120 megabytes. Hudi Parquet small file size limit is set to 100 megabytes. Again, you can use the default option, but if you want to configure your own file size, you can do so. So what's going to happen, guys, is, I have said that Hudi that, hey, I want a 120 megabyte file, right? So when the write comes, so again, the first write will go into this blue file, then the green file, and the red file. So 20 megabytes here, 30 megabytes here, and again, in the red file, I have 120 megabytes. Now, as you know, the blue and the green file, there is more space there, right? So next time when I insert something, that can go into those files, right? So as you can see over here, what happens is the next 100 megabyte will go into the blue file together, which is now 120 megabyte, right? Similarly, the green file has 90 more megabytes. So that will essentially go into the green file. So hopefully this makes the concept clear about Hudi file sizing. Now, one more thing I want to specify here is when you set Hudi Parquet small file size limit to 0, what happens? So let's take a look at that. So during the first time, right, you have your 20 megabytes, 30 megabytes, and 120 megabytes because the file size is 120 megabytes, right? So now when the next time a new insert comes, right, what Hudi is going to do, it's going to basically put them into the new file group. So the next time the new insert, it's going to create a brown file, and you can see it's going to create a purple file, and only updates will be touching your older files. So this can lead to creating smaller files. But again, if ingestion latency is critical, then you can set this parameter to 0. So hopefully that made sense. I'm going to close this diagram and back to the code base. And over here, guys, all I'm doing is I have a simple for loop, and based on the flag, I'm simply appending those Hudi settings into the dictionary. As you can see, all these are a bunch of if statement. If I want to use cleaner, if it is true, add the settings into the dictionary. So I'm simply adding the settings. It's all I'm doing. And here at the end, I have an if statement on line 206. I'm saying, hey, if the Spark data frame has data, which means if the count is greater than 0, come inside. And basically, at times, if I want to transform the data, I can simply also provide a SQL query. So basically, all I'm doing here is if SQL transformer is equal to true, I simply create a temp view over here, and then it's going to execute the SQL query that you provide if you want to do any transformation. But again, hopefully that made sense. And over here, all we do is perform an append operation. So this function in general is all it does is basically performs an upsert into a Hudi transactional data lake. And it takes a bunch of flags such as cleaner, HiveSync, DynamoDB log. And based on the flag, whether it's true or false, it's going to apply those settings into the table. Now let's take a look at one of the tables. So now if we go back to the job details, scroll down, going to the advanced properties over here, right? Keep scrolling down. Now observe over here. For the user table, I'm specifying, I do not want to use cleaner. So I'm specifying the word false, which means that particular settings is not going to be added. If you want to make it true, you can make it true. DynamoDB log, Hudi again, supports concurrent writes as well. So you can use DynamoDB as a log table. But again, I'm setting it to false for now. HiveSync as true, meaning I want to catalog, I want to use glue to catalog that, right? So I'm specifying HiveSync as true. I'm specifying I want to partition my data. I'm specifying the glue database as writes DB. I'm specifying the table name as user because again, it's user, right? So the precon key is created at, meaning if I have the same user, let's say you made an update to the user, Hudi is going to take the max of that. So hopefully, this is going to be used for dedo purposes as well. Hudi has a record key, also called as primary key. We are using a user ID as a record key. Table type as copy on write. Hudi has two table type, as you saw in the presentation, copy on write and merge on read. Index type, I'm using Bloom. But again, if you need uniqueness across all the partition, Nadine can help you with the links. You can also use global Bloom, which ensures uniqueness across all the partitions. Yeah, then we are partitioning our data lake Hudi table by state, right? The source file as Parquet. Here you can see the source S3 path. If I copy this quickly, and if I open that in the notepad, this is the path to our raw table. Again, this would be a different bucket. So I'm just showing you for mine, raw table name as user, right? So hopefully that made sense. So I'm going to close that. Then we have the target. So meaning where do I want to create my Hudi transactional data lake? So I am creating my Hudi transactional data lake in a folder called Silver, and the table name is going to be user. So you can verify that. And again, if you are using Glue 4.0, Hudi is natively supported. All you got to do is simply use a flag and specify the data lake format as Hudi, and that's it. So hopefully that made sense. And now what you want to do is you want to save this. And one more thing that I want to walk you over is the bookmark. So if I can quickly show you over here. So we are using Glue bookmark, meaning I only want to process new data. So the next time when I run, if there is no data, no new data on the raw folder, again, it's not going to process it. So hopefully that made sense. I want to process only the new data. So I'm using a bookmark, a Glue bookmark, right? And now all I got to do is simply run this file. And now if you observe, this job is now in the running state, right? Now, what I want you to do is do this same for the other tables, for example, for the drivers. So you can review the code, you can review the parameters. So I want to simply click on run for the drivers. Then I want to run probably the tips. I will click on the run button over here. So 3 jobs are running. Then I also want to run the writes. So I'm going to run this one as well. So I'm running 4 jobs right now, right? So it's going to read from S3 and create our silver table, right? So if I go to S3 at this point, I should not have a silver zone. As you can see, I do not have any folder starting with the word silver. So the jobs are now in the running state. What you can do is come here and click on job run monitoring. If you click here, you can see the statuses of all your Glue job. And as you can see, these all Glue jobs are currently running. They're all reading data from S3. They're going to create your Hudi transactional data lake. So we can wait here for a while. So hopefully this job shall be complete. It would take about 2 to 3 minutes, depending how many records you have, right? All of these Glue jobs are also scheduled, meaning they're going to run on a cron. So for example, I'm just going to show you any one of them. So if you click on schedule, as you can see, we have scheduled all the jobs to run daily at 8 a.m. You can run it on a frequency about 5 minutes, 1 hour, depending upon your use case. So I just wanted to walk you over that part. And let me pause here and wait for the jobs to complete. And if you have any questions, please post them in the comments or unmute yourself so that I can answer those questions.
Oh yeah, Sumil, should you run the date dimension jobs too, or no?
Oh yeah, you're right. I forgot about that. So yeah.
Yeah. So
I'm
there's
gonna yeah,
so
go ahead.
there's a lot of Glue ETL jobs. Make sure you're running users, drivers, rides,
Yes.
tips, and the date dimension
And the
one.
date dimension.
The
So,
rest of them don't run yet. So go ahead
yes.
and run the date dimension, and let's see your dashboard so people can know which ones you're running.
Perfect. I'm running the date dimension as well. So I'm running 5 Glue jobs, drivers, users, rides, tips, and date dimensions. So hopefully that made sense. And if I come to job monitoring, as you can see, 5 jobs are in the running state right now. So we're gonna wait. As you can see, let's see if this is complete.
I have 5 running too. Yeah, mine is.
Perfect. One of them is complete. So let's wait for all of them to complete. So please, everybody, go ahead and run these Glue jobs. And if you have questions, please unmute yourself and ask the questions.
And then you can see the status on job running monitoring on the left now.
Yes, that is correct. So as you can see, 3 jobs have been completed. And we're just gonna wait for the rest 2 of them.
Sumil, I have a question here.
Yes, please
The
go
Glue
ahead.
job you have configured, the Glue bookmark thing. That
Yes.
is for incremental purpose, right?
Yes.
How are you going to capture the CDC at that point of time? If there is any updates or insert, or update or delete happened.
Yes.
How that incremental or the Glue will know that?
Oh, yeah, great. So AWS Glue has implemented bookmark. They take care of this logic. They make sure that only the new files that have been added in that raw folders are processed. Does that answer your question? But I do want to mention, I have made my own version of bookmark as well. Later on, if needed, I could share the links for the code base. But yeah, Glue takes care of that.
Understood. Okay.
So we have another question. One of the questions is what do we have to keep in mind when choosing COW versus MOR storage types? I'll share blocks to follow up what I'm saying. There's a couple articles devoted to this, but basically merge on read tables have fast writes because you're writing to these log files. So the first ingestion you do or the first commit is a Parquet file, and then any writes happen subsequently go to these log files until a compaction service is triggered, which combines all the log files into a new version of the Parquet files. I can show back in the presentation what this might look like. But essentially MOR, because of the fast writes, MOR tables are really good for streaming data where you need to support fast writes, and they just get written to these log files. And the write amplification is very low for MOR tables. Now COW tables is more optimized, I would say, for more or less, lack of a better word, batch ingestion. Where you're not working too much with streaming data and you want to be able to get those fast writes and the tighter SLAs on the write latency. And this is when you would want to choose a copy on write table. So that's kind of the main difference between these 2 table types. Hudi is very unique. A lot of databases use copy on write data warehouses or a copy on write and stuff. Hudi is very unique where it strongly supports streaming data, not only in the table type it supports by writing to these log files, incremental queries, updates, indexing. So Hudi is very, very optimized to efficiently and effectively handle streaming data. And by having these 2 table types, it's just one of the ways that it supports streaming use cases.
That makes sense. Thank you, Nadine. Thank you so much for that. Any other questions on Hudi over here? Happy to answer them.
Yeah, I have one quick question. So
Yes,
let's say
quick.
any of the jobs when writes the data to S3,
Yes.
let it be COR or MOR type. Let's say MOR type, but because the logs will be stored in the log file and we are not compacting the files there and there. But at that same time, if any downstream application like let's say Athena or any BI tool connects to S3 and try to read the data, how that Athena or any other tool will understand, or will it just get the data from the Parquet
Yeah.
file, or do we need any layer? There to Hudi kind of layer to read the data? Yeah, I think you got my question. What I'm saying.
Yes. I'll answer part of it, and then Nadine can answer the rest. Hudi, when you create an MOR table, you will see two tables in the glue catalog, starting with the word RO and RT. RO stands for read optimize, and RT stands for real time. So your downstream application can consume from the RT tables, and your queries can be done on RO table. You can also run snapshot queries to consume the data. And Nadine, if you want to add to that.
So what was the second part that I'm adding to?
If you want to add anything to that.
Oh, for the I think that covers it. What would you yeah. There are 3 different query types that you can run for MOR tables depending on what you want to do. The snapshot query is a little bit more intensive because you're always getting the current view, including querying the log files to get that view. The read optimize query just queries basically like the Parquet files after either on T0 where you have your first commit or subsequently after a compaction.
Okay. So it's the table that is going to get created in the data catalog.
Yes.
I think you said R underscore or something, through which we can decide on what data we are looking for, right? And then we can read. And this is in case of MOR type, right?
Yes.
Yeah.
For COW, it's going to compact the data there and there only. So any downstream application can directly read the data from the Parquet files. Okay,
Yeah, it does emerge automatically through the time of
Yeah.
ingestion each time. And that's why
Each
you
time.
have these Parquet files. That's why if you look on the raw data, well, actually it's just your first commit. It doesn't make any difference. But anytime you have a commit, it's these Parquet files. That's why the write amplification is higher for COW tables.
Yeah, get it. Yeah. Thank you.
Yeah.
Thanks.
So you would be now, please head over to the databases and click on WritesDB, and you will see 5 Apache Hudi tables here in the glue catalog. We'll click on one of them just to show you a little bit. So for example, if I click on, let's say, writes, right? So here you can see all the columns that you have. They are corresponding data types and whether you have partitioned it or not, right? Additionally, I do want to mention that if you have extremely large table, Hudi tables, you can add indexes. So for example, I'm going to show you for one of them probably. So for example, let's go to probably users. You can go to indexes and you can click on add index. And then you can probably say, I guess state. And you can click here and you can click on update. This is going to create an index on a glue table. So again, if you have large tables, probably petabyte, right? And if you have partitioned it by a year or month day, I would recommend setting up indexes on a year or a month so that you can filter out the data. So hopefully that made sense. And now what you can do is open up Athena. So since we have cataloged the data, you can run ad hoc queries at this point. So let's go to Athena and just run a simple ad hoc query. So over Athena, you will click on this orange button that says launch query editor. And then what you want to do is you want to head over to S3 and I'm going to click on create folder and I'm going to create a folder called Athena results so that, all my results are dumped into this folder. And let me put this one here and click this orange button. And here you can see I have a folder here. On the top right-hand side corner, I'm going to click on copy S3 URI, and then I'm going to head back to my Athena console, which is over here. I will be navigating to the settings and then manage. And over here, I will paste the S3 path, right? And then I'm going to click on save. I do want to mention a bit about lifecycle policy. You can definitely read more about it. So as you're going to run all these queries using Athena or whatever query engine it is, right? These results are going to be dumped into the S3 folder, right? over the time that can pile up. So what you want to do is you want to set up life cycles so the objects will transition from standard to infrequent access and eventually into Glacier, or you can also delete them if needed. This can help you to save cost as well. So now you can click on this orange button, which is save, and then head over to the editor over here. Now you can query your Hudi tables. You can select the database as writes DB. And here you can see, I can see all the tables. For example, I'm gonna click on this 3 dot and click on preview table. And I should be able to see the data in for my tips table. So as you can see, I have write 3 and write 2, and I see $7.96 and $4.39. This records resemble what is there in DynamoDB. So let's quickly check DynamoDB if we have this records. So if we go back to DynamoDB quickly, and if I go to tables, if I go to tips, I click on the orange button that says explore, and here you can see $7.96, $4.39. So now your DynamoDB table is synced with your Apache Hudi. Again, as you keep adding more data, and these glue jobs are going to run on a cron, right? So your transactional data lakes are going to be in sync with your DynamoDB. So everyone, so far good with these steps? Any questions?
Yeah, just one question.
Yes,
Through Glue data catalog, we are querying the Athena tables, right?
You are right, yes.
Of course, that's a way. But if we directly create table on top of S3 by any other tool or something, then can we see the similar kind of data, or we need Glue data catalog only?
You can use, I mean, you can also run through, let's say you're running Presto, you can query the data as well. Let's say you're running a Spark SQL, you can directly read the data, Hudi tables, and run SQL queries on that. We are going to see that in the incremental part.
Okay. Thank you.
No problem. Any other questions? Okay. So let's see the documentation. I believe we have completed the part 3. So what we have done so far, I'm just going to simply recap. We have a DynamoDB table. We have streamed everything into the raw zone. From there, we used Glue to create these transactional data lakes. We created user, drivers, writes, tips, and the date dimension. And now I just want to show you quickly the S3. You will see something called as silver. So if I refresh here and I click here, you can see I see a folder called silver. And here you can see these are your Hudi transactional data lake, right? So for example, if I click on, let's say, writes, here you can see it's nicely partitioned by a year. I have a month, right? I can go inside a month, then I have a day partition. And then these are your Parquet files, and Hudi will maintain the metadata for you, right? So basically, if I quickly go here, just want to point that out because Nadeem pointed out during the presentation. So here you can see about the timeline, everything, all the commits. Hudi is maintained inside a folder called .hudi. Any questions so far before we proceed further?
Yeah, sorry to ask you again. Which job has created the silver folder? The different glue jobs?
So we had 5 glue jobs. The user, the drivers, the date dimension. So these are reading from the raw zone, and they're creating your Hudi tables, basically.
Okay.
Any other questions? All right. If there are no questions, we proceed. All right. This is one of the most interesting part about Hudi. I really love it. It's about the incremental data processing. So now what we're going to do is basically the company or the business wants to analyze the driver's earning, right? How much tip they are making. So we are going to build a fact table, and basically we will be reading data incrementally from writes. We're going to be reading data incrementally from tips. We're going to join the data, and then we're going to create this fact table. Now, there are 2 cases over here, which I want to talk about. Is case number 1, when you have writes and tips, right? You're going to perform a join, and you're going to insert that data into the Hudi fact table, right? Straightforward. Case number 2 is the most interesting one. Is you're going to tip the driver later on, which is considered as a late arriving tip. In this case, you have a tip, but no writes. In this case, what you're gonna do is we're gonna read the data from the fact table, then we're gonna read incrementally from tips, and then we're gonna update just that particular record. Imagine if you had a petabyte scale data lake. This is so convenient because you don't have to scan the entire table, right? So that is why I say this is one of the most interesting part about the workshop. So now we're gonna proceed with the incremental ETL, okay? So I'm gonna share my screen and we're gonna go to the code base. Let me put this over here on the top. So we're going to go over incremental ingestion.py. It's a lot of code, so I'll try my best to explain what we are doing over here. Before that, what I want to do is I want to cover a small flowchart just to go over how we are querying the data in Hudi in an incremental fashion. So I'm going to open this image that I have. Let's see if this opens up. So this is the logic or the code logic that we have for incremental processing. So let me try to put this image over here on the bottom. It's a little annoying here. And this one also, if I can put on the top. Okay. So what does it do is basically the code will start. It will check if you have a metadata file or not. So there are two possibilities, whether you have or you have not, right? When you're running for the first time, you do not have a metadata file, right? So what it's going to do is it's going to load the data and it's going to get the begin time, right? Then it's going to perform an incremental query and get all the data. And then it's going to get the last commit and it's going to store that on the S3. So next time when you run, it's going to say, hey, do you have a metadata file? The answer is yes, I do have a metadata file. All right, well, let me open that file. It's going to read the commit. And again, it's going to perform an incremental query and only get new data. So that is the logic. So hopefully the logic is pretty straightforward. It stores the commit on S3 as a checkpoint or a metadata, however you want to call, and then it performs an incremental query. So now we're going to take a deep dive at the code. All right, let me put this one over here. I have essentially made a helper class for you, so things are a little easy for you. The class name is Hudi incremental reader. And let me see if I have a flowchart. It's all right. So the way this works is you need to provide the bucket name, the bucket that is used for checkpoint or the metadata purposes. You provide the Hudi table name. You provide the Hudi path where your transactional data lake is. We're going to provide the silver zone, right? We provide the Spark session, and then we're going to invoke the read method over here. Again, behind the scenes, it does all the incremental queries, which I'm going to show you shortly. But on a high level, I want to make sure this makes sense. So all we do is we create an instance of a class Hudi incremental reader. We pass in these configuration, and we invoke a method called read. This will basically perform all the incremental queries, and it's going to return you the Spark data frame. Okay. Now let's take a little bit deeper dive at the code, what it actually does. So I'm going to go from the top to bottom. So over here, I have all the imports that I need. I'm defining a Spark session, glue context, Bodo3, pandas, UUID, OSS, JSON, regular expression, RE, right? So I'm defining all of that. Over here, I'm declaring all my Hudi tables that I want to read, right? So I'm defining the writes table, right? So the Hudi table for the writes, Hudi table for the tips, which is again all in the silver zone, right? We ran the glue job. We have the silver zone right now. This is where the fact table is going to be created, right? That is the gold zone, right? Then this is the date dimension. So this is the path to my Hudi transactional data lake. Over here, I create a Spark session, very straightforward, just creating a Spark session over here, right? Now, on the top level, we have three classes. I'm mostly interested in the class Hudi incremental reads. If you see, you have a method called read, okay? And now what it does is basically behind the scene, it calls a run method. It's a private method. This is a public method. So I'm gonna click on the run. Now, again, this is all the logic that I was explaining you on the flowchart. So it basically calls a method check metadata file, which means it's going to say, hey, do you have a metadata on S3? The answer is yes or no. For the first time when you're running, the answer is no, you do not have a metadata file. So what it's going to do, it's basically going to get the begin commit, the first commit that the Hudi has. It's going to grab that, it's gonna call a function called read incremental data, passes in the commit, right? And then after that, it grabs the last commit and basically push the metadata on S3. Because why? Next time when I run, I want to resume from the last commit, right? Because I already processed the data, right? I want to process incrementally. So now let's take a look at these methods in a little detail. Let's go inside the private method get begin commit. Again, it's a class. You don't have to know. If you want to know, it's a good thing to know, right? So I'm going to go inside the class get begin commit. If you observe, what it does is basically it creates a Hudi snapshot. It creates a temp view called Hudi snapshot. And here I am using a Spark SQL query. I'm grabbing the Hudi commit distinct, and I'm essentially then sorting that by in an ascending order, right? And then I'm grabbing the first one out of that. So I'm grabbing the begin commit, and the function returns the begin commit to me. Coming down, then we have a method called read incremental data. This is the method that performs incremental query in Hudi. I'm going to click on that. As you can see, this method here, you can see we are creating a query. Hudi data source query type, incremental, meaning we are saying Hudi, hey Hudi, I would like to query the data in an incremental fashion. Then we say Hudi data source read begin instant time. We provide in the commit, right? So it's gonna now read the data incrementally. So now I'm basically creating a temp view called Hudi incremental. And here you can see I'm using Spark SQL. I'm saying select everything from Hudi incremental. I'm returning that Spark data frame object. Okay. So again, in a layman language, what this does is basically performs incremental query, returns a Spark data frame. Okay. Coming down. Now, once we have that, I have a method for last commit, because next time when you want to run, you want to get the new data, right? So I have a method here. Again, all it does basically queries Hudi incremental, orders the commit time and grabs the last one, right? So hopefully that made sense. And then all we do is we push this metadata on S3. So next time when you run, it's gonna load this metadata file, and it's gonna perform the incremental query from the last commit, which is saved on S3. We're gonna see all this in action shortly. So that's the else part. Again, the if part is pretty straightforward. If you have a metadata, read the metadata, print the metadata on the console, grab the commit. Once you get the commit, perform an incremental query, check if the data frame object is not empty. If it is not empty, then and only then push the metadata file. Because if the data frame is empty, which means you don't have any data to process, it can throw an error, right? So I simply have a check over here. So let's collapse this. So all we are doing over here is we are reading data from writes table. I'm providing the table name. I'm providing the data lake path, and then I'm providing the Spark session. Similarly, I'm doing that for the tips. I'm reading the data from the tips. I'm providing the tips path, which is defined on the top, right, as a variable, and I'm providing in the Spark session. So that's that. Then what do? I am invoking the read method on both of them. So I'm getting the data in an incremental fashion from writes. I'm getting the data from an incremental fashion from the tips. And I'm simply doing .show. So when you open up, the CloudWatch, you can see the data frame printed just for debugging purposes, right? Now, what do I do after that? I create a temp view. I'm creating a temp view called writes. I'm creating a temp view called tips, and I'm creating the temp view for date dimension. Now, what I'm going to do is I'm going to head over to the slide just to show you the schema so that the SQL queries make sense. Okay. So let me see if I can find the PowerPoint. If I have that open up, which I should. Nadine, can you please send me the PowerPoint? I think I have it over here.
Yeah, let me send you the
link, or else I can open up. It's all right.
I'll send it to you right now. Hold on, give me 1 second. All right, check your PM. I got it.
All right, thank you so much.
Yeah.
All right. Looks like it says an access. So let me unshare my screen for a second, and I'm going to open up those slides and then share my screen back. Okay.
Oh, wait, did I send you the wrong one? I think I sent you the wrong one. Hold on.
I think I got the slides, so it should be all right. I think I have the slides now. I'm going to share my screen back. So let me share my screen. Do you guys see my screen now?
Yeah, you're good.
All right, so I'm gonna head over to this particular slide, which has the schema. So hopefully when I explain the joins, that makes sense. So I'm gonna go over here. And what I'm gonna do is I'm gonna say presenter view. And try to minimize this. Okay, everybody, can you guys see my screen now?
Yes.
All right, so this is the main part, right? So we wanna build this fact table, right? So what are we doing, right? I am reading the date dimension, right? Creating a temp view, right? I'm reading data from the rights table incrementally, right? Using that class that I just showed you. I'm reading data from tips table incrementally and creating a temp view. Now, what do I have to do? I have to join all these data. For that, I'm using SQL because I like SQL. It is easy, right? So I'm going to use Spark SQL. So this particular table, as you can see, it has a driver ID, a ride ID, a fare amount, total amount, tip amount, and the date dimension key for the date, right? So now, as you can see, there are two cases, right? A, when you have a rides and a tips, in which case it's easy. You know, the total earning for the driver is the fare amount plus the tip amount that you gave the driver. And that's the total amount, right? Case 2 is when you tip the driver later on, what you got to do, you got to read the fact table, then you got to read the data from the tips incrementally, and you have to update the tip amount and the total amount, right? So two cases, again, as I said. So now let's see the query. Now this should make sense what I'm saying, right? So we made these temp view, so rides, tips, and date dimension, okay? Now, these are the two cases that I talked about. Case number 1, when you have rides and tips, both of them, what are we gonna do? We're gonna join the data. So as you can see, I'm using Spark SQL, and I'll try my best to explain you the query. Select r.driver ID. So I'm selecting the driver ID. r.ride ID. I'm selecting the ride ID from the rights table. I'm selecting the fare from the right table. I'm using the word coalesces. So now what this does is basically, it means if you have a tip amount in the data frame, use the tip. If you do not find that, use the default as 0, because I may have tip or I may not have tip. It might come later on, I don't know, right? So I'm specifying the default value over here. And how much did the driver run is basically r.fare, how much you paid for the rides, right? And then I'm using coalesces t.tip amount, meaning I'm saying take the tips from the tips table. If you don't find, use 0. So it's gonna basically take the ride. Let's say you paid $20 plus, if you did not tip the driver, so 20 plus 0. So the total earning is $20 US. And this is the date dimension key. So you can slice and dice the data on the date dimension, hopefully, right? So I'm using the word from rides. So I'm selecting that from the rides table. And if you observe, I'm doing a left join on ride ID. So let me just show you this one. So if you see the tips table has a ride ID, right? And the right table also has a ride ID. So I'm simply performing a left join, and I'm saying why left join? Because I may or may not have the tips data, and hence I'm not doing an inner join, I'm doing a left join, okay? So I'm doing that, and then what I do is basically I need the date dimension key, right? So observe how I'm doing that. So select date underscore key, and then I'm using the word to date. I'm specifying the column date underscore key. On date dimension, you have a column called date key. And I'm specifying the format in which it is there, right? So I'm saying YYY MMDD as date, okay? I'm selecting from the date dimension Hudi table that we just created in the silver zone. And then if you observe, I'm basically using the rights date, right? And my right date is in the format year -month -day, right? So this particular thing is going to populate my date dimension key. So this is the data for the fact table, okay? So hopefully that made sense. Now let's take a look at the next part. Over here, I have a upsert method. I'm calling, I want to create a gold zone, right? So database name, table name is going to be drivers earning, record key. So if you see here, I'm using a composite key, meaning I'm using driver and ride. I'm specifying them by a comma. You can do that in Hudi. In fact, pre-com key, I'm simply using ride ID, right? So hopefully that makes sense. And then I'm passing in the Spark data frame. Table type, I'm saying Hudi, hey, Hudi, I want to use copy on write, and I want to perform an upsert on the table. Okay. Now, this is the most interesting case, which we're going to take a look after we run the code. This is about the late arriving tip. So when you tip the driver, right, it's going to come later on, right? So you took a ride and then later, maybe tomorrow, you got an alert on the application and you said, oh, let me tip $1,000, right? You tip the driver. So in that case, what we do is, again, we read the data from the fact table and we read that as a temp view called drivers earning. We perform an SQL query. So hopefully this will make sense. So now observe over here. I'm selecting the driver ID. I'm selecting the ride ID from the fact table. DE stands for the fact table. Selecting the fare, right, from the fact table. I'm using the word colasses for the tip because I have got a tip later on, right? So colasses t.tip. If I don't find, I'm using 0 and I'm updating the total amount. Because when you tip the driver later on, I want to update that particular row, right? So I'm saying de.fare, meaning whatever fare you have in the fact, add tip amount to that and select that as a total amount. Hopefully makes sense. And again, now simply doing a join, and hopefully that's the SQL query. And then what we do, we perform an upsert on a Hudi transactional data lake. Now, with that being said, let me take a pause for about a minute before I run the code. Any questions? We can take 1 or 2 questions.
Yeah, I have a question.
Yes, go ahead, please.
So the metadata read and update that you had.
Yes.
So is something to do with Hudi itself, or is it some plain JSON file where you're tracking what's the last commit I processed?
Great question. So basically what I did is it's basically a simple JSON file on S3, and all it does, or it helps me to identify the commit time I stored there on S3, and then I load there, I parse there, and I simply perform an incremental query on the next time. So it's a JSON file, yeah.
Okay.
Any other questions?
Yeah, but all these JSON files and metadata, is created through Hudi only, and we don't have to worry about that. We just have to make sure with the logic that we are reading the correct metadata file in order to see whether it's the first commit or.
So the template that I wrote, so I wrote a class for you guys, so you can use this class. It takes care of all of that. So you don't have to specify the metadata file name. So whatever Hudi table you're using, that's gonna, behind the scene, it takes care of the file name and everything. I'm gonna show you all of that in a second.
Right. Yeah. Okay.
So, Saumil, can you confirm that again? Does that JSON file have anything to do with Hudi itself, or is it just your way of doing it now, just to store what's the last?
It's my way. I implemented a helper utility function, which you can use. You can implement your own version as well. But this is a class that I wrote since I had a use case. And again, you can tweak and you can change based on your needs as well.
Okay, got it.
All right. I guess now we're going to see this in action, the incremental ETL finally. So what I'm going to do is now I will.
I have a question, Saumil.
Go ahead, please.
Like in Athena, we like build the table, we catalog the table, and we can query on top of those tables, right? In Athena.
The voice is sort of cracking. Maybe somebody, if you can repeat the question, Nadine.
Or yeah, if you want to type it really quickly, because the audio is breaking up.
Okay.
We'll answer it live, just so we understand the question.
Okay. So once that question comes in, Nadine, maybe you can speak that.
Yeah.
All right. Meanwhile, I guess I can proceed in the meanwhile. So please head over to the ETL jobs. And now we are going to run the incremental ETL, the most fun part about the workshop. So I'm going to click on incremental ingestion. And hopefully now I give you a deep dive on the code base, how or what's happening, right? Let's go quickly over the job details. Using Spark, again, Glue 4.0, right? Using G1X, again, when you have more tables, you can increase the workers, you can increase the instance type. But for now, I'm just using G1X. Then using glue bookmarks over here. Then if you come to the job details section, here you can see data lake form as a Hudi, providing in the conf over here, database name as RightsDB, and the bucket name, right? So hopefully that makes sense. So now all you have to do is simply, before I run this, I want to make sure I show you the S3. So if I go to the S3, I have a lot of tabs. I need to close all of these. All right. If you see over here, I do not have any folder called metadata. Okay, just want to show you. I'm going to run the job and then I'm going to show you what happens behind the scene. Okay, so now I will run the job and where is the job? Here, this one. All right, so now we're going to run the job. Now this can take about 3 to 4 minutes, depending upon how many records you have ingested. And in the meanwhile, if you guys have questions, I'm happy to answer your questions.
Yeah, Sujit asked, can we hide some columns in Athena for tables for end users? And then I said, you can select the columns you want. And I said,
Yes, that is correct. Yes, that is correct. And also on the
oh, there's more to this. He says, not while querying, but while showing to end users who will query on top of the tables. So I don't think you want to, do you mean like role-based access, Sujit?
No, like the path name of the table and the metadata of the table.
Oh, I see. Okay, I think I understood the question. Please let me know if it is incorrect. So Sujit, you are asking, hey, can I hide those columns, for example, commit time and all of those metadata?
Yeah.
Is that the answer? Is you can do that. So when you're committing into your transaction data lake, you can select the column that you need. So yes, you can do that. Also, when you go to the table section over here, quickly want to show you. Again, you can define the schema as well. So here you can see in the schema section, you can click on edit JSON. You can simply remove or add stuff based on your need. Does that answer the question, Sujit?
Yeah, thanks.
Perfect, thank you. All right, so meanwhile, if you have questions, please do ask. This will take about 1 to 2 more minutes, probably.
One more question. Like, is there any possibility for the Hudi tables to be like not in the incremental form?
Is there a possibility? Could you explain me a little bit, please?
So let's say in your star schema tables,
Yes.
Can there be any table with like no incremental?
Yeah, I think I understand. You're saying, can I just do a full load? Is that what you're? Yeah. So if you see in the code, the date dimension, right? I'm not reading date dimension in an incremental fashion because anytime I perform anything on the fact table, I would need to read the date dimension. So I'm reading complete data from the date dimension. Does that answer your question, Sujit? You're on mute.
Yeah.
Okay, thank you. The way you can do that, I'm just going to quickly show you. So here you can see how you can read all the data from Hudi, right? So spark.read.format, you specify the format as Hudi, you use the word .load, you specify the path where your Hudi tables are, maybe on S3 or anywhere else. And then all I'm doing is just creating a temp view so I can run like Spark SQL queries. So this one right here will read all the data from that table. So I think the job is it is complete. So yeah, as you can see, the job is now complete. Now, before I go to Athena and show you all that stuff, I want to show you the S3 first. So what I'm gonna do, I will go to S3 over here, and I'm simply gonna refresh. And as you can see over here, I have a gold zone, right? So we have raw, silver, and gold. And also, let me see, there should be a metadata file. Yeah, metadata. So as you can see, there are 2 JSON files, writes and tips. I'm going to download one of them to just show you what I'm doing. So again, as I said, I'm simply maintaining the metadata so I can perform incremental queries. So I'm just going to open that up quickly in Notepad. So if I do Notepad++, and my computer is a bit slow, so sorry about that. Let me see if I can. So if you guys can see, last process commit, this is the last process commit on Hudi. Then the table name is writes, the path where that table is. So again, I'm storing that in the JSON file as a string JSON, right? Inserted time, when was this inserted? Again, it's just my own version again, but you can definitely take the code that I have and tweak that if needed. Hopefully, does that make sense? So next time when I run, what it's going to do is it's going to read this file and it's going to say, all right, I got to perform an incremental query from this particular commit. So that is what it does, basically. Now, what we're going to do is I'm going to go to the S3. And if you see, we see a gold zone. We see that earning table. And here you can see the Parquet file. And what we're going to do, going to go to Athena. I think I have it over here. If I refresh over here, excuse me, here you can see drivers earning. Click on those 3 dots and click on preview table. I'm just going to run that. And here you can see your fact table. You have a ride, you know, what was the fare amount, how much he or she tipped the driver, right? The total amount. And this is the key to the date dimension. So you can slice and dice the data. Let me take a pause here and see if you guys have any questions. We are at 2:25, so probably just one question, and then we can proceed.
So, quick question. Here, the incremental loading, we are only doing for rides and tips and not for any other tables, right?
Correct. That is correct. Yes.
Okay, good. Thanks.
All right. So with that, now we're going to do the most interesting part. We're going to tip the driver. So I'm going to take a screenshot and then I'm going to tip the driver and we'll see that being updated over here. That's the most interesting part. So I'm going to take my snipping tool over here and I'm going to copy this just for reference. And now let's go to the workshop lab. And I believe part 4, build fact tables, this one incremental. All right, so now what you're gonna do is you will copy this particular JSON in Notepad or whichever one you like. And then let's head over to Athena, probably. So over here, let's say I wanna tip this particular ride number 4, okay? So the base fare was $95.74. And now I'm very generous and I want to tip the driver. So I'm gonna use this ride 4. So I'm gonna come here and change this to 4. You can change based on the data that you have on your Athena. So I'm gonna change this to 4, and then I'm gonna tip the guy $1,000, a lot more, but it's okay. He did a good job. So $1,000 tip. This is the ride ID, and I'm gonna give some unique number. Probably gonna copy this. Now we're gonna see how the entire data flows. So we're gonna make this insert on DynamoDB, okay? And what would happen is the Lambda function is gonna get the event, is gonna store it into the raw zone. We're gonna run the glue job. It will go into the silver zone, and then from silver zone, we go to the gold zone, okay? So hopefully that's the flow. So now I will be heading over back to my DynamoDB. I click on the tables. I click on the tip amount. Yeah, tip, that's right there. And then I click here, and then I'm gonna click on the button that says create item. Click on JSON viewer, and then I'm gonna copy this. Okay, and here you can see for ride 4, I'm gonna tip about $1,000 US. I'm gonna click on create item. So as you can see, now this particular tip has been added in Dynamo, and this should in near real time flow into the raw zone. So now what we're gonna do is we're gonna head back to our glue job, go to the ETL jobs, and we're gonna run tips. So we have to create the silver zone, right? We have it in the raw zone. We have to now run the tips glue job. So for now, I'm gonna click on Hudi tips. Okay. Now again, it's gonna process incrementally. So it's not gonna process the old data. It's gonna only process the new data that came in because we are using glue bookmark. I'm gonna go to the run section. I can click on this button run, and this would take about probably 2 minutes roughly. And once we have the tip, then we can run the incremental ETL, and you will see the fact table will be updated. So
section we'll query the data to show the updates, and then we'll get into the Quicksight section.
That's correct.
And I think we'll be able to finish in time.
Hopefully. Hopefully.
Yeah, we can go through a couple of dashboards and then leave some for you guys to do.
This sandbox accounts will be available, I'm assuming, till the end of the day. Nadine can.
Yeah, let me email Jangam to see if we can extend it 1 day so you guys can kind of run through it. Let me send an email now while we're waiting.
Somil, I have a question.
Yeah, go ahead, please.
Yeah, so can you please explain me what is the difference between CDC and the incremental
Oh, yeah, sure. So CDC or change data capture is a way to capture changes on any databases. For example, let's say Postgres or MySQL or Dynamo. So anytime you insert, anytime you update, anytime you delete something, you can capture that. Again, there are various tools. You can use Debezium. Debezium you can use. Then you can also use AWS DMS to capture all the changes, right? And then incremental is basically, anything changes happening in the data lake, you want to capture those in an incremental fashion. You don't want to perform a scan on the entire data lake. So that's incremental. Does that make sense?
So CDC is like capturing the updated data on the whole database or the whole table.
So basically the previous and the after version of the data, any changes that happens on the data.
And incremental is like based on the time duration. Let's say 2 days incremental. Any update or deletion has been happened in last 2 days.
Yeah, you could run point-in-time queries as well. So you can say, I want to query in this particular point in time. So Hudi has that as well. Yeah.
Okay.
So this job is complete. Now, if you are running this together with me, head over to your Athena and see, do a preview table on tips. And let's see if you do see 1,000. Okay, as you can see that right for tip ID 100, and then the tip amount is $1,000 US. So which means we were able to fetch this data from Dynamo and we were able to sync that into our transactional data lake, which is Hudi, right? Great, absolutely fantastic. Now what do we gotta do? We want to update the fact table, right? So I still have that screenshot over here. As you can see, that was for the right number 4, $95.74. When I add $1,000, it'll be $1,095.74. So let's see if that works. So now what I'm gonna do is I'm gonna head over to Glue Jobs. Where's my Glue Jobs? This one, I guess. All right, and I'll go to the ETL jobs. Click on incremental ingestion. And all I need to do is simply run that particular job. So I'm going to wait for the job to complete. Now, what I'm expecting is, it's going to read the data from S3, from the metadata or the JSON file. It's going to perform this incremental query, which means it will be able to identify the new tip, which was added into the Hudi table. It's going to read the fact table and it's going to update that particular row. So let's see that in action now. So I'm simply refreshing here. And again, all these pipelines are scheduled, meaning they're going to run daily. But if you have a specific use case and if you want to orchestrate that, you can use step functions, you can use Glue workflow as well to do that. So again, hopefully that makes sense. So let's wait here. Again, might take about a minute or so.
Yeah. And then after the incremental, we'll run a query to see the update and then we'll go.
That is correct. And then you query and build real-time dashboards, 1 minute, almost there.
So if you guys are not part of the Slack channel, the Hudi Slack channel, and join the AWS Hudi Ride Workshop, please join there. Gotten some messages that people have been waiting, and I sent out an email to join the Slack channel so we can monitor stuff. So please join the channel to ask questions after the workshop and things like this.
So let's wait about 1 more minute, probably. And again, if your job failed, we also have a retry mechanism, meaning it will automatically retry for 3 times. You can increase that as well. So, that also has been taken care in the jobs. So let's refresh.
So that JSON.
Yeah,
sorry.
go ahead. Yeah, go ahead.
That JSON file is going to be overwritten, right? It's going to update.
You're absolutely correct. Yes, 100%. That is correct. You're right. So you will see a new comment there. You're right.
Right. Yeah.
All right. Almost there. 2 minutes, 15 seconds. Hopefully works.
And otherwise, if you do not use that mechanism, which you have implemented of,
Yeah,
that
you gotta write that logic. Maybe use a CSV, I mean, whatever you prefer based on your use cases. But
No, but no. In case if we don't have that mechanism, it will just simply read all the data from there, and we won't be able to. Yeah, and we just want to limit it to the newly loaded data only, so that we can process the incremental data and load it into the fact table.
You're right. That is correct.
Yeah.
So you're reducing the processing time, right? But instead of reading all the data, you're only reading the new data, which means it saves time, it saves cost, because now you don't have to use that many workers, right? For more big data, right? So I guess this job is complete, and I'm very, very excited to see that particular tip now. So hopefully that works. Let's see. All right, so table. Come on, please work.
And then
there. So you see how the incremental ETL works. This is the before part, right? You had a $95.74. We added $1,000 tip. So you can see this tip amount was updated and the total earning was updated. So you see how Hudi is shining here, right? You're only processing new data in an incremental fashion. And as a case study, I would also recommend to read Uber's incremental ETL pipeline. I guess the links are in the chat for that as well. Over to Nadine for the next parts. Thank you.
Yep. We'll pause here if there's any more questions, and then we'll take the next 10 or 15 minutes to do the real-time dashboard. We'll build a dashboard or two, and I think you guys will be able to run with it for the rest of the workshop. Okay, so actually let me stop sharing really quick. Let me pull out 1 second.
So Somil, I have a question.
Yeah, go ahead.
In the table which we queried, so we get the latest data regarding that particular record, right?
Yes.
If we have to go, let's say, to the previous version of that particular record, so how do we do that?
Oh yeah, great question, Sujit. So basically, are you asking for backfilling purposes?
Yeah.
So I think I forgot to cover save points. So you can take checkpoints and you can basically roll back in time to that particular version. So Hudi offers checkpointing mechanism. I think we can cover that based on the Nadine. Can we cover checkpoints if we have some time?
Yeah, let's get through the dashboards, and if we have some time at the end, we can cover.
Perfect.
Yeah, we can cover save point.
Perfect. Thank you.
Yeah. Just to come full circle with the workshop. Okay, so the first thing we're gonna do is you guys are gonna navigate to Athena. So you can just type Athena service in the search bar, and then you'll see like some tabs open. So what we'll do is the first query is actually in workshop part 5 under write analytical queries. Samil, if you want to type the query in the chat box.
Yes, I will do that from the links.
Yeah. So what we're gonna do is we're gonna create different views. And I'm gonna change this to RidesDB. Okay. So we're gonna create different views, and all this query is basically doing is just doing like a simple casting and aggregation of the total fare. So it's just doing a casting in it. So it's just one step into building some more complicated queries. And then what we're gonna do is we're gonna go ahead and run it. And then you'll see the query is successful. Now, if you navigate to views, you'll see that there's a view called total fare. And then if you want to preview the view, you can. And then if you run it, you'll see what the fare decimal is. So that's the first view. It's just an aggregation of the ride's total fare. That's all it's doing. So we'll go ahead and create some more views. So the next view we're going to do is we're going to calculate the driver's earning over a month and a year. And so Samil, if you want to paste the second query in the box. Oh yeah, in the query, please replace Uber with RidesDB. We made some changes and I didn't get a chance to update the workshop. I'll update it after this, but just change Uber to RidesDB and the rest should be fine. So to open up a new query editor, you can just go ahead and click the plus button. And then I'm just going to make some changes really quick from Uber to RidesDB. Oh, actually, these are fine. Oh, wait. Just checking the query really quickly.
Looks good, I guess.
I guess
Yeah,
Okay, it's just the first one I didn't add. Okay, let's go ahead and run this query. Mismatch drivers.
might have a space. I think you have a space on line 3 and line. Can you remove the space and try that? Yeah, try that, please.
If that would that cause
Yeah.
it? Oh, that did cause
You
it.
guys are a little bit picky on the space, you know.
Well, yeah. Some editors are not. Okay, so then you'll see a view like this, the gold drivers earning month here. We're just querying the business or gold layer. And then finally, where the last SQL query we're gonna get the top 5 drivers who made the most tips. And then we're gonna use that. So we're gonna go ahead and copy the code if you want to paste it. And then I'm gonna get rid of the space. And then I'm gonna just check the query really quick. Okay, all this looks fine. And I'm gonna go ahead and run it. So we're just creating 3 different types of views. And you'll see the views pop up in the bottom over here on the bottom left. So the next thing that we're going to do is we're going to actually build near real-time dashboards. So what we're going to do is I'm going to keep this editor up. I'm going to actually navigate to Quicksight. So you can just type in Quicksight on the navigation. And it's going to ask you to sign up. This is even if you have your own AWS account, you have to do this. So just click sign up for Quicksight. Just click the free version and then click continue. And I don't know, click yes. This is just a demo account. Okay, let me move this. This is really big. Hold on, I can't see this. All right.
Nadine, your screen is cutting a little off. So could you scroll a little bit towards your left, please?
Yeah, I can't actually. It's actually hard. Everything is. I can't even see it.
No worries. That is all right.
Yeah, just click I am federated identities. Make sure you're in US East 1 on the region. Quicksight account name, enter a quick, we'll just type in, I'll just type in my name, workshop demo, and then notification email. You can just type that in. These accounts will be closed anyway, so they'll be turned down. And then I am role, just do the manage role is fine. And then this is the most important part.
Yeah.
Click on select S3 buckets because it's not checked. Check the bucket where you have your account ID and where the business level analytics is stored and stuff like that. Make sure you check that and then click finish on the bottom right. Oh, write permissions for Athena work group. We're not going to write to it, but you can just click it just in case. And then click finish. So now you have the Amazon S3 and you have 1 bucket selected. You should see this updated. Make sure you collect this or else you won't be able to visualize the dashboard. And then click finish. And then click continue. Click yes. A provided account not available. Go back. What?
Might have to give a unique name there. Something.
Okay, let me just type in 1. Okay.
Yeah. That should work, hopefully.
And then if you have to go back, you have to reselect your buckets. So make sure you always continue to go back and reselect the bucket with your account name. Okay, let's see if this works.
Perfect. Yeah, the name has to be unique, guys. Okay.
Okay, yeah. And then you should create your Quicksight account.
Mm-hmm.
So now what we're going to do is we're going to go to, we're going to build our first dashboard. So go to Amazon Quicksight. It's just taking a while to get there. And then you can just close this little pop-up box. You're going to click on new analysis. And then you're going to click on new data set. And then you're going to click on Athena. Right here. And then you're just going to enter a data source name. So the way that I just did it is I'm just going to type in total fare. And I'm just going to put that over here so we know what it is. And I'm just going to type in 1. And I'm going to go ahead, primary, that's fine. Primary workup, yeah, that's fine. And then you can just go ahead and create a data source. So we're going to be using the AWS data catalog. And then you're going to choose as the database RidesDB. And then what we're going to do is we're going to use the total fare. This is the query we just written, a few moments ago, and we're going to visualize that query. So typically you want to write your queries in Athena, whatever business analytics, and then you can pick that view and then use that. So I'm going to go ahead and click select. And then I'm going to go ahead and click on direct query from the thing, just in case there are updates. You'll be able to directly query your data. And then I'm going to go ahead and click on visualize. And then you can click on interactive sheet, that's fine. So the next thing I'm going to do is that you can just drag and drop here. And it should be able to query it, and then you'll get your results. And then for the second and third dashboards, it's actually the same thing. So we can go ahead and quickly add, you can go back and follow the same steps. So we can go ahead and save that. And then we can go ahead and go back to requerying it. So if I go back to Quicksight again, we can go ahead and do a new analysis. You can click on new data sets, Athena. And then if we go back to the query editor, we can do gold rides, Uber month year. I'll just type that in and I'll just put 1 there. Create data source. You're going to choose the RidesDB. And in this case, we are doing Uber month year, this one, Uber month year, select it, and then just click visualize. Oh, actually directly query data. Anyways, it wouldn't matter because we're not going to get updates. And then what I'm going to do is that it's loading right now. We're going to put in ride counts. Oh, there's no data. I think it's still querying.
Yeah, it will take time because it's now importing in Spice. So it would take a bit time now.
Yeah. But the same thing, you will drag and drop ride count and then month, and you'll be able to visualize it. It just might take a moment. And this is how we create the queries. We build the levels, we query it, and then we create some analytics. This concept is applicable outside of AWS as well. But it's easy to work with Glue, and if you're using EMR as well. Okay, let me try this again.
Right now, maybe.
Yeah, this should work.
Try dragging to the target. Well, yeah, no.
Okay, so then we're going to drag in month, and I'm going to drag in ride count. It should do that. It should form like
yeah, you got to put down the target value. So drag it on the
yeah. Let me do that. Hold on. I don't know. Add measure here. It's clicking. Okay. Okay.
I think we just gotta select the chart type, but yeah, the bar chart, whatever chart we need, and then
yeah, let's try that. There we go.
There you go.
Or I can just do something like this.
So it's pretty much like a Tableau or any Power BI tool, you drag and drop and then you build your dashboards,
Yeah. So this kind of, you'll do the same thing for the other query that we did, but this pretty much kind of brings us full circle to the workshop.